information these probes send back contains disturbing warnings or revelations that challenge everything we thought we knew about the universe. What if the very fabric of our understanding is questioned? Join us as we take an in-depth look at the discoveries made by the Voyager missions, particularly Voyager 1, and the alarming messages it has conveyed about the future of space exploration and our place in the universe. For nearly half a century, the Voyager missions have led the charge in space exploration. These twin spacecraft have provided scientists with a treasure trove of data, offering insights into the mysteries of our solar system and the broader universe. The sheer duration of these missions is nothing short of remarkable, considering they were initially designed to last only 5 years. Yet, they continue to operate, far outliving their expected lifespans, and providing an enormous amount of data along the way. The history of the Voyager program is captivating in its own right. It began with the accidental discovery by a young NASA scientist, Michael Minovich, who realized that a spacecraft could use a planet's gravitational pull to slingshot itself further into space. This revolutionary concept allowed the spacecraft to travel much farther than previously thought possible, setting the stage for the launch of the Voyager missions. In 1977, Voyager 1 and Voyager 2 were launched, their primary mission to study the gas giants Jupiter and Saturn. These two planets had long been of great interest to scientists, with their immense size, complex atmospheres, and numerous moons. What the Voyagers accomplished, however, exceeded all expectations. Both spacecraft are equipped with 3.5-meter parabolic antennas that communicate with Earth, along with 16 thrusters to adjust their orientation and ensure their antennas remain pointed toward our planet. Their engines run on hydrazine fuel, and their onboard electronics are powered by thermoelectric generators, fueled by plutonium. In addition to these remarkable features, each probe carried 11 scientific instruments. These tools were designed to study the planets they encountered, from analyzing atmospheric conditions to examining magnetic fields. Over time, as the probes moved further from their original targets, some of these instruments were shut down, but many continue to function, sending back valuable data. One of the most ambitious parts of the Voyager missions was the so-called Grand Tour of the Outer Planets. This tour became one of the greatest achievements in the history of space exploration. Voyager 2, in particular, achieved the distinction of being the first spacecraft to closely observe Uranus in 1986 and Neptune in 1989. These encounters provided scientists with unprecedented views of these distant planets and their moons. Voyager 1, which had overtaken Voyager 2 just a few months after its launch, conducted flybys of Jupiter in 1979 and Saturn in 1980. These encounters made Voyager 1 the most distant man-made object from Earth, a title it still holds to this day. Despite the immense distances both probes have traveled, they continue to operate, with Voyager 2 currently functioning with 5 active instruments. Voyager 1 has 4. Together, these probes are valuable information regions of the solar system and the vastness of beyond. Spacecraft venture farther from the Sun's influence and into interstellar space, they continue to send back crucial data about the cosmic environment they encounter. Data is helping scientists piece together a better understanding of the space between stars, a region that had remained explored until now. But before we dive into the mysterious messages Voyager 1 has sent back, let's take a moment to appreciate the profound 2 missions have made along the way. Imagine embarking on an epic voyage to explore the unknown regions of our solar system, with Voyager 1 and Voyager 2 as your companions. Their first mission was to take a detailed look at the majestic Jupiter and Saturn system, exceeded beyond anyone's expectations. The images and data sent back by the Voyagers transformed our understanding of these gas giants. They revealed the intricate cloud patterns and turbulent weather systems of Jupiter, including its iconic Great Red Spot, a massive storm that has raged for centuries. The probes also provided new insights into Saturn's complex ring system, capturing stunningly detailed images that allowed scientists to study its composition and structure like never before. As Voyager 1 moved beyond Saturn and out of the solar system, Voyager 2 still had exciting targets ahead. In 1981, a carefully planned maneuver adjusted its course, setting it on a path toward Uranus. By 1986, long past its expected lifetime, Voyager 2 arrived at Uranus, where it made one of its most significant discoveries. The probe identified 10 previously unknown moons, expanding our knowledge of Uranus's satellite system. These moons had gone undetected by earlier telescopes, but Voyager 2's instruments captured their presence, adding them to the growing list of Uranus's known companions. Yet, the journey didn't end at Uranus. Voyager 2 pressed onward toward Neptune, its final planetary destination. In 1989, it sent back more than 9,000 images of Neptune and its moons, leading to the astonishing discovery of 9 new moons. Among these, Triton, Neptune's largest moon, revealed secrets that astounded scientists. Its diameter turned out to be different than previously thought, and it had surprisingly few craters for a moon of its size. More intriguingly, Voyager 2's data revealed that Triton's whitish-brown color was due to geysers spewing liquid nitrogen, which froze upon contact with the surface, creating a landscape of nitrogen snow. The Voyager missions left an indelible mark on our understanding of the solar system's outer planets. No other probe has since returned to Uranus or Neptune, and scientists continue to study the data collected during those historic flybys. The discoveries made by Voyager 2 at Uranus and Neptune have spurred ongoing interest in these icy giants, prompting further investigation by scientists around the world. Uranus, one of the lesser-known planets in our solar system, is classified as an ice giant, along with its neighbor Neptune. Despite the cold connotations of its name, much of Uranus is not frozen. Instead, the planet consists primarily of supercritical fluids, high-temperature, high-pressure substances that combine the properties of liquids and gases. Uranus is located about 1.8 billion kilometers from the Sun, making it the second most distant planet in the solar system. With a diameter over 4 times that of Earth, it is an immense planet. Yet, one of its most curious characteristics is its sideways rotation. Unlike most planets, which rotate in an upright position relative to their orbits, Uranus rotates on its side. Scientists speculate that a massive collision with a protoplanet in the distant past may have caused this unusual tilt. This event might also explain the presence of the 27 moons that orbit Uranus, possibly formed from the debris of the impact. Even more fascinating, about a decade ago, the Hubble Space Telescope detected a massive storm in Uranus's atmosphere, a gigantic white spot with winds reaching up to 143 km per hour. In addition to these violent weather systems, Uranus is home to frigid clouds composed of methane and ammonia, where temperatures can plummet to -197 degrees Celsius. While less prominent than Saturn's, Uranus also has a faint ring system, composed of dark, dispersed material. Neptune, discovered in 1846, holds the title of the most distant planet in our solar system. Located nearly 5 billion kilometers from the Sun, it exists in near-total isolation, far removed from the warmth and light of the inner solar system. To put its distance in perspective, the Earth is only 150 million kilometers from the Sun, while Neptune is more than 30 times that distance. Despite its remoteness, Neptune shares many similarities with its neighbor Uranus, including its size. With a diameter of roughly 50,000 kilometers, Neptune is comparable to Uranus in scale. However, it takes much longer to complete an orbit around the Sun, 165 years to be exact, while it spins on its axis rapidly, completing a full rotation in just 16 hours. When Voyager 2 visited Neptune in 1989, it observed extreme weather phenomena, including bright cloud bands and massive storms with winds reaching speeds of 2,100 km per hour, the fastest ever recorded in our solar system. Scientists believe that the low levels of solar energy reaching Neptune might allow these storms to reach such incredible velocities. However, these storms are not permanent, they may eventually dissipate or disappear. One of the most famous features Voyager 2 observed was the Great Dark Spot, a massive storm system similar to Jupiter's Great Red Spot. But when astronomers attempted to locate the few years later, it had vanished. Scientists theorized that Neptune's core caused atmospheric to the storm's disappearance. Neptune's core remains one of the great mysteries of planetary science. Despite the planet's turbulent atmosphere, scientists estimate that its core is composed of rock and metal, with a mass between 1 and 1.5 times that of Earth. Temperatures within Neptune's core are thought to soar to nearly 13,000 degrees Fahrenheit, and pressures can reach several million bars. Both Uranus and Neptune also have highly unusual magnetic fields, which have long puzzled scientists. Unlike Earth, where the magnetic field is closely aligned with the planet's rotational axis, the magnetic fields of Uranus and Neptune are significantly tilted, adding to the mystery surrounding these distant giants. Now, as the Voyager missions push further into interstellar space, they continue to send back data that challenges our understanding of the universe. Voyager 1 has crossed into the region beyond the Sun's influence, where it has encountered surprising phenomena, including the detection of strange, unexplained signals. These signals, combined with data from Voyager 2, raise important questions about the nature of interstellar space and the future of space exploration. As we analyze the disturbing messages sent back by the Voyager probes, we are reminded that the universe is far more complex and mysterious than we once believed. Let me know what you think in the comments section. If you enjoyed this deep dive into the Voyager missions and the incredible discoveries they've made, be sure to like the video and subscribe for more space exploration content.
Could Proxima b be another Earth-like planet? These are speculations everyone keeps making. The search for an alternative habitable planet and alien life is something that fascinates humans. There have been various speculations, and the fact that signals have been detected from Proxima b makes people believe there is more to it. Despite these signs, we have yet to determine if these are messages from the planet or simply echoes of our own signals. Often, these signals end up being echoes, but scientists hope to determine if they are truly from Proxima b, which could confirm the existence of alien life. Recently, the James Webb Telescope detected artificial lights on Proxima b. If you're interested in learning more about other planets and the progress in finding alternate life, subscribe to our channel. We create content about outer space and discuss innovations in science. If you like this content, comment below and share this video with your friends. Now, let's dive back into our video. Proxima Centauri, located about 4.2 light-years from our solar system, is a faint dwarf star classified as a GV star. This star is known as Proxima Centauri, the closest to our Sun and solar system. It was named Alpha Centauri by Johann Bayer in 1603. Derived from the star's ascension at noon, while several celestial bodies like the Moon and the Sun were in a straight line. Proxima Centauri is also referred to as Alpha Centauri or Alpha Centaur. It is part of a single star system with 4 main stars in alignment, and Proxima Centauri is at the center of this system. Alongside the 4 stars, there are 2 faint dwarfs, Alpha Centauri A, also called Rigil Kentaurus, and Alpha Centauri B. These stars contribute to the bulk of the system's mass but are too faint to be seen by the naked eye. This system is located about 23 degrees away from the border of the famous Plough asterism in the constellation Centaurus. Even though Proxima b is a rocky planet, there is hope that it might host extraterrestrial life. The search for other life forms has brought scientists to Proxima b, as its similarities to Earth's size and distance from its dwarf star make it a viable option for supporting life. While these are just speculations, there is hope that there might be some truth to them. There is still much to learn about Proxima b and its orbit, so stay tuned for more information. You can also check out some of our other content related to extraterrestrials. Do you believe there is other life out there? Leave a comment below. What fascinates most people about Proxima b is its similarity to Earth. Studies show that Proxima b is an exoplanet that orbits an M-type star with a mass 1.27 times that of Earth. Proxima b takes 11.5 days to complete its orbit around its star. It was discovered in 2016, and many scientists are still studying it. While Proxima b appears similar to Earth, certain features make it uninhabitable. For one, the planet is too close to its star, resulting in extreme ultraviolet radiation. This radiation is estimated to be hundreds of times stronger than what we receive from the Sun, stripping away light hydrogen molecules over time and doing the same to oxygen and nitrogen. While some may argue that Proxima b should be habitable because it is at a similar distance from its star as Earth is from the Sun, there is more to consider. Distance alone does not guarantee the presence of water or an atmosphere conducive to life. Earth's atmosphere is what makes it habitable, not just its distance from the Sun. The right atmosphere enables climate regulation and a water-friendly surface while shielding living organisms from hazardous space weather. If you're with us so far and haven't subscribed yet, take a second to hit the subscribe button. It helps us keep creating content like this that you'll enjoy. Now, let's explore why people think the James Webb Telescope will help us determine if there is life on Proxima b. The James Webb Telescope was launched in 2018 after being delayed since 2011. Many changes were made to ensure it provided accurate images. Loeb explained that if a planet like Proxima b could absorb light from its star, it could also re-emit it as infrared light. The James Webb Telescope was specifically designed to observe infrared light. It can take photos of this light on a planet's surface and look for patterns that could confirm the presence of water or an atmosphere. One reason space telescopes are preferred over ground-based ones is that, being above Earth's atmosphere, they don't have to peer through shifting air, providing a clearer view of deep space. This allows them to observe what ground telescopes cannot. Additionally, space telescopes are not affected by weather changes on Earth, ensuring clear readings. However, the downside of space telescopes is that repairing them is expensive. If something goes wrong, an entire mission into space may be required to fix even a small flaw, which can be costly. Observing planets like Proxima b is difficult with the James Webb Telescope, and there is no option for rescue if something goes wrong, since it has been launched over 1.5 million kilometers away, further than any human has ever traveled. Rescue missions are not an option. The James Webb Telescope comes with a larger mirror, allowing us to see way back to the beginning of the universe, almost 13.7 billion years ago. The further away an object is, the further in time we get to see it. This happens because it takes a while for light to travel from an object back to us. The ability of the James Webb Space Telescope to see the universe in a longer wavelength in infrared light means we get to see more distant galaxies in our universe with more certainty than was previously possible. Therefore, observing planets like Proxima b has become easier, and it has pushed the light out of the visible range and into the infrared. Tabor and Loeb have a scale of artificial illumination as a fraction of how the sun illuminates and reflects on the day side of the planet. At 0% on the scale, one would assume that the planet's night side is completely dark with no illumination. At 100%, it means that the planet's night side is just as bright as the day side. There has been speculation about a hypothetical civilization on Proxima b using this type of light, and most scientists believe it is similar to the early days on Earth. The studies show that if the night side of Proxima b reaches an illumination of 5% of the natural day side, then the James Webb Telescope could detect the artificial light by 85%. If the illumination reached 9%, the telescope would detect up to 95%. Even though 5% illumination sounds like a small number, we're talking about the light from a star as far away as Proxima Centauri, which is 20,000 times dimmer than our sun, yet we still have a lot of light from our star. This means that even at 0.01% of illumination, we are still reflected in the stellar illumination. In other words, if Proxima b has any civilization disguised as glowing like Earth, the James Webb Telescope would not detect it. The stars would need to be about 500 times brighter. This scenario is impossible since Proxima b orbits so closely to its host star that it might be tidally locked, meaning one side of the planet always faces or is in perpetual night. A civilization living on a tidally locked planet might need to focus on illuminating infrastructure and use very bright orbital mirrors to reflect sunlight from the day side to the night side of the planet. All these are speculations made by Tabor and Loeb, and there is yet to be proof to show that it is true. Earth's illumination can be seen from outer space and is known as airglow. Most people wonder why the world is surrounded by bright shades of red, yellow, green, and purple light when viewed from 300 miles above its surface. The airglow happens when atoms and molecules in the upper atmosphere produce light to release excess energy. On Earth, the airglow can occur when atoms and molecules get ionized by sunlight and capture free electrons. The glow seems similar to an aurora, except that auroras are driven by high-energy particles from the solar wind, while the airglow is driven daily by solar radiation. Since the James Webb Telescope's launch, scientists have been asking whether it is sufficient to view other planets in faraway galaxies. Even though it is the furthest satellite telescope launched, it still provides very little data needed to find planets with life in other galaxies. As such, there have been conversations about developing bigger and better telescopes. These ventures are often costly and involve a lot of trial and error. The James Webb Space Telescope launch was 7 years late due to these issues. Therefore, it is challenging for most scientists to develop better innovations that can be launched further into space. Despite this, the James Webb Space Telescope's results are promising, and soon we might know if there is life on Proxima b and other planets. While work is still being done on more telescopes, it is believed that the completion and launch of the Habitable Exoplanet Observatory, HABEX, will revolutionize space study. The estimated completion time of HABEX is 2035, with a launch soon after. HABEX will be sensitive to all planets in the universe, although its main objective is to search for Earth-like planets. Its advanced technology will enable it to measure the spectra of most planets and determine if they are habitable. HABEX is also believed to have a broad range of astrophysics capabilities, enabling it to study the earliest possible times in the universe's history, gather information, and understand the life cycles and deaths of massive stars, as well as the elements that support life as we know it. Even though HABEX is still in manufacturing, the technology used to make it will allow it to study Earth-like. President Biden has introduced the first image to be shown publicly from the James Webb Telescope. Throughout history, countless instruments have been created to explore space, yet none have matched the leaps made by science with the James Webb Telescope. This telescope was designed for a remarkable journey back to the universe's birth, and it has delivered. We now have the clearest image ever of the City of Lights, altering our understanding of space. Join us as we delve into this incredible discovery by the James Webb Telescope and its implications for the future. This marvel of human ingenuity is no ordinary telescope. It stands as the largest and most powerful space telescope ever built, set to revolutionize our comprehension of the cosmos with its cutting-edge technology. With the JWST's capabilities, scientists can peer back to when the universe was just 200 million years old, effectively rewinding the cosmic clock. Moreover, the telescope can capture images of the earliest galaxies ever formed, revealing the universe's first stars twinkling in the dark void. Even on paper, its power surpasses anything seen before. The James Webb Space Telescope embarked on its journey on December 25, 2021, riding aboard a European Ariane 5 rocket from the verdant forests of South America. With a budget exceeding $1 billion and the collaborative efforts of thousands of scientists spanning 3 decades, this technological marvel soared into space. The launch carried immense risks, as failure loomed as a possibility, yet the mission proceeded flawlessly. After a journey spanning nearly 1 million miles over 30 days, the telescope reached its permanent home at Lagrange 2, a gravitationally stable location opposite the Sun relative to Earth's orbit. As the James Webb Space Telescope commenced its mission, NASA outlined 4 main areas of study: observing the universe's first light, studying galaxy assembly, exploring star and protoplanetary system formation, and investigating planets and the origins of life. These endeavors are crucial for advancing our understanding of space, as they delve into realms previously challenging to explore. Before beginning its astronomical observations, the telescope underwent critical science and calibration tests. Among these tests, deploying the sunshield was pivotal. This 5-layered membrane shields the telescope's sensitive instruments from the sun's heat and light, safeguarding its longevity and functionality in space. Following the successful deployment of the sunshield, the next crucial step was to deploy the telescope itself. Although in the right position, precise alignment of the JWST's 18 hexagonal mirror segments was necessary to ensure sharp imaging. Each segment must align perfectly to fulfill its intended purpose. The deployment of the telescope was an intricate and delicate process, involving multiple steps such as unfolding the sunshield, extending the telescope support structure, and gradually deploying the primary mirror. Achieving precise alignment was crucial for scientific observations, and any error in this process could result in significant financial loss. Moreover, it wasn't just about deploying the telescope. It also had to remain stable. Calibration tests included activating the telescope's scientific instruments one by one to ensure their proper functioning. These instruments, including the near-infrared camera, the near-infrared spectrograph, and the mid-infrared instrument, each had specific capabilities for observing the universe. Following instrument activation, the telescope underwent precise alignment with its target objects in space through a process called commissioning. This involved observing calibration targets and adjusting the telescope's pointing and tracking systems. All these tests were imperative to ensure the JWST's readiness for its mission of exploring the universe. The successful execution of these complex procedures fueled excitement in the scientific community. Involving over 300 universities, organizations, and companies from 29 U.S. states and 14 countries, the JWST project was truly international in scope. After passing every test, NASA gave the green light for the James Webb Space Telescope to begin its scientific mission in July 2022. With all 17 of the observatory's scientific instrument modes fully vetted, the JWST embarked on its journey of discovery. Unlike other telescopes, the JWST sees in the infrared spectrum, enabling it to capture light beyond what human eyes can perceive. This capability, combined with its massive size, allows it to observe smaller, more distant objects without atmospheric interference, earning it the moniker, Eyes on the Universe. The JWST's operation relies on a 21-foot mirror to capture and reflect light to its instruments, which include the near-infrared camera, the near-infrared spectrograph, the mid-infrared instrument, and the fine guidance sensor. Each instrument serves a specific purpose, from capturing stunning images of distant galaxies to studying exoplanets and our solar system. Infrared light, with its longer wavelengths compared to visible light, offers valuable insights into celestial phenomena that would otherwise remain concealed. This choice of infrared technology underscores the JWST's capacity to unveil hidden aspects of the cosmos, marking a significant advancement in astronomical observation. Earth's atmosphere acts as a barrier, blocking much of the infrared light that reaches us. This limitation underscores the need for specialized telescopes like the JWST to capture this elusive light. The significance lies in the concept of redshift, a consequence of the universe's expansion. As objects move away from us, the light they emit becomes stretched towards the red end of the spectrum. By observing this redshifted light, we effectively peer back in time, glimpsing the early universe's conditions, including the formation of stars and galaxies. The JWST's capability to detect infrared light enables it to capture this extremely redshifted light from objects billions of light-years away. This ability allows the telescope to act as a time machine, providing insights into the universe's past. When the JWST observes distant galaxies, it's not merely witnessing their present appearance, but rather how they appeared billions of years ago when their light first began its journey through space. In July 2022, NASA unveiled the first science images taken by the JWST during a live event. These images, including views of the Carina Nebula's cosmic cliffs and the Southern Ring Nebula, showcased the telescope's capabilities. Additionally, the JWST's analysis of exoplanet WASP-96b's atmosphere and observations of Stephan's quintet offered valuable scientific insights into cosmic phenomena and galactic interactions. The release of the JWST's first science-quality image, showcasing the deepest infrared view of the universe to date, marked a significant milestone. President Joe Biden, Vice President Kamala Harris, and NASA Administrator Bill Nelson unveiled this image, depicting a mosaic of 18 scattered bright dots, which represented the star HD 8446. This image hinted at the telescope's potential for further exploration. Subsequent progress revealed the JWST's continued advancements. In February 2022, NASA released an improved image of HD 8446, demonstrating the telescope's capability to align and focus the scattered star images into a deliberate hexagonal formation. This process, known as image stacking, resulted in a clearer, more detailed view of the star, showcasing the JWST's evolving potential for scientific discovery in the cosmos. The James Webb Space Telescope even captured a unique selfie using a specialized camera within the NIRCam instrument, designed for engineering and alignment purposes. In this image, one mirror segment appeared brighter than the others, indicating successful alignment and pointing towards a star. Subsequently, all mirror segments were aligned individually, showcasing the telescope's precision and accuracy. One of the JWST's significant discoveries was its deeper exploration of the Eagle Nebula, renowned for its towering columns of gas and dust. While the Hubble Space Telescope captured the beauty of these formations, the JWST's infrared imaging revealed the hidden processes within them. The latest image from the JWST unveiled numerous protostars, appearing as tiny red dots against the nebula's backdrop. These protostars, within vast collections of dust and gas, represent the birthplaces of stars. The image, composed using infrared wavelengths, offers insights into the early stages of star formation. Anton Kamor, a research astronomer, explained that while visible parts of the image appear blue, they would appear red to the naked eye. This color variation correlates with increasing radiation wavelengths, providing valuable information about star formation processes. Additionally, the JWST's advanced instruments, including coronagraphs, have revolutionized exoplanet observation. Within a year of its launch, the JWST made history by capturing its first direct image of an exoplanet, named HIP 65426b. This gas giant, located exceptionally far from its host star, presents opportunities to understand planetary formation and explore the potential for life beyond our solar system. These breakthroughs mark transformative moments in astronomy, offering glimpses into the universe's origins and the possibility of habitable exoplanets. Despite challenges such as the rarity of habitable planets, continued research, fueled by instruments like the JWST, holds promise for unraveling the mysteries of the cosmos. The James Webb Telescope's capacity to closely scrutinize planets suggests that it could be the primary instrument for detecting a potentially habitable exoplanet, should one exist. However, the telescope's achievements extend far beyond exoplanets. Recently, scientists revealed that it successfully observed the oldest galaxies known to humankind. These galaxies were formed during a time when the universe was just 2% of its current age, residing at an extraordinary distance of approximately 13.4 billion light-years away from Earth. The JWST's exceptional infrared capabilities played a pivotal role in detecting these ancient galaxies, allowing it to capture images from a cosmic epoch over 13 billion years in the past. Identifying these ancient galaxies posed a significant challenge given their immense distance. Nevertheless, the JWST's advanced instruments, such as the near-infrared spectrograph, enabled scientists to measure their redshift accurately, thereby confirming their age. These galaxies' existence predates the birth of the first stars in our own Milky Way galaxy, providing a profound insight into the universe's infancy. Moreover, researchers have speculated about the JWST's potential to capture the clearest image of city lights ever seen in history. Proxima b, an exoplanet located within the habitable zone of Proxima Centauri, the nearest star to our Sun, offers tantalizing prospects for harboring technological civilizations. Researchers theorize that the JWST could potentially detect artificial illumination on Proxima b's permanent night side, opening up new avenues for understanding distant worlds and potential extraterrestrial life. The JWST's remarkable discoveries underscore its pivotal role in pushing the boundaries of astronomical exploration. While it has already achieved remarkable feats, the promise of future space telescopes, such as NASA's proposed Large Ultraviolet Optical Infrared Surveyor, holds the potential for even more groundbreaking discoveries. These advancements serve as a poignant reminder of the vast mysteries that await exploration in the cosmos, with telescopes like the JWST serving as our beacon of discovery.
The Space Telescope has revealed unprecedented views of Jupiter, and the James Webb Telescope took the picture. This advanced telescope has also spotted intriguing city-like lights over 7 trillion kilometers from Earth while observing Proxima Centauri b, our closest exoplanet. This discovery raises the possibility of advanced civilizations beyond our solar system, stirring excitement among scientists and space enthusiasts who have long awaited evidence of extraterrestrial life. The lights, resembling those of a distant city, suggest the potential presence of an organized civilization on Proxima Centauri b. If confirmed, this breakthrough could be a major step toward proving that intelligent life exists beyond Earth. The scientific community is both amazed and hopeful at the possibility. This unprecedented finding suggests that advanced civilizations might exist outside our solar system, fueling the idea that sentient life may have been waiting for us to develop the technology to find it. David Kipping, a Columbia University astronomer, notes that Proxima Centauri b is particularly difficult to study due to its unique heating pattern, which differs from typical rocky planets. Unlike other planets that absorb sunlight and emit infrared radiation predictably, Proxima Centauri b has a distinct infrared signature from its star, Proxima Centauri, making it an intriguing subject for further research. The James Webb Space Telescope, JWST, has played a crucial role in this discovery by capturing Proxima Centauri b's unique thermal signature with its advanced infrared capabilities. This allows scientists to explore the exoplanet's atmosphere and assess its potential for supporting life. The JWST's ability to detect faint signals from deep space makes it ideal for uncovering the mysteries of this distant planet, including the city-like lights observed on its night side. The telescope is specifically designed to detect even the faintest light, making it perfect for identifying whether the lights are artificial or natural. Proxima Centauri b's unique thermal and atmospheric properties make it a compelling subject for further study. The planet's surface and stellar characteristics interact in complex ways, with significant temperature and heat distribution changes between day and night. The day side of Proxima Centauri b likely features large solar panels that absorb energy from its star and reflect light. If the exoplanet has an atmosphere, it would smooth out temperature variations, leading to more stable conditions. Without an atmosphere, the temperature difference would be extreme, with the day side intensely hot and the night side freezing cold. Understanding this temperature variation is crucial for assessing the planet's atmospheric composition. The JWST's advanced infrared imaging can detail the planet's thermal emissions, potentially indicating whether Proxima Centauri b has an atmosphere and what it contains. Finding gases like oxygen, water vapor, and methane would suggest potential habitability. However, the JWST cannot detect bonded oxygen, a key indicator of life. Despite this limitation, the telescope is essential for identifying other signs of life, such as ozone. Future telescopes and observatories may be better equipped to detect these elements on distant exoplanets. While the JWST can only examine a few nearby habitable planets, the upcoming Extremely Large Telescope, ELT, set to begin operations in 2028, will offer deeper insights into distant exoplanets' atmospheres. The ELT data will provide a clearer view of these planets' habitability and the potential for life elsewhere in the universe. As new telescopes are launched, the JWST will remain a key player in exploring distant exoplanets despite its limitations. The insights it offers into planetary atmospheres and life conditions could lead to groundbreaking discoveries. The telescope hints at the future of exoplanet exploration, showcasing the potential for improved space study and tools. A major goal for upcoming space telescopes is to enhance the detection of faint light from exoplanets by reducing the brightness of their host stars. Current methods involve using internal masks or large external satellite-like umbrellas to block starlight, allowing a clearer focus on the planet's reflected light. This is similar to shading your eyes to better see a distant object. If successful, these techniques will help scientists analyze a planet's atmosphere and assess its habitability. However, significant challenges remain, such as distinguishing gases from biological versus geological sources, which complicates the search for life. Many essential life gases can also come from non-biological processes, risking false positives. Despite these hurdles, astronomers are committed to refining their methods to detect genuine signs of life and filter out false signals. The James Webb Space Telescope's early findings offer a promising glimpse into the future of exoplanet exploration. As humanity pushes further into space, ongoing research is expected to reveal more about the universe and our place within it. The quest for extraterrestrial life continues strongly despite decades of effort. The discovery of city-like lights on Proxima Centauri b may be the closest humanity has come to finding evidence of extraterrestrial life. Whether these lights will prove to be humanity's long-sought answer or present a new mystery, the quest to uncover the unknown persists. This timeless curiosity about whether we are alone in the universe has driven stories, research, and philosophical debates throughout history. Today, the search for extraterrestrial life is a serious scientific endeavor, led by advanced technology probing deep space for clues. Central to this mission is the James Webb Space Telescope, JWST, our most advanced tool for exploring the universe. Once considered the stuff of science fiction, many scientists now believe in the possibility of extraterrestrial civilizations. The Search for Extraterrestrial Intelligence, SETI, founded in 1984 by Jill Tarter and Thomas Pearson, seeks to detect intelligent life through radio signals. Radio waves, unlike other types of radiation, can travel vast distances with minimal scattering. SETI uses the Allen Telescope Array in California to search for these signals, though no definitive evidence has been found yet. Despite this, Tarter remains hopeful, urging active public participation in the search. Excitement surged throughout the scientific community when the James Webb Space Telescope, JWST, detected what appeared to be city-like lights on Proxima Centauri b, a planet located just over 4 light-years away from Earth. This incredible discovery immediately sparked widespread speculation and hope, as many wondered if these lights might be artificial in origin, potentially providing groundbreaking evidence of an extraterrestrial society. If proven to be the result of intelligent activity, such a finding would be one of the most significant discoveries in human history. It would confirm what generations of scientists, philosophers, and dreamers have long hypothesized, that we are not alone in the universe. Proxima Centauri b has long been a subject of intrigue, given its status as the closest exoplanet to our solar system, orbiting Proxima Centauri, the smallest and faintest star in the Alpha Centauri star system. This planet is thought to lie within its star's habitable zone, the region around a star where conditions might be right for liquid water and potentially life to exist. Given this proximity and its position in the habitable zone, Proxima Centauri b has been one of the primary targets in the search for extraterrestrial life. However, detecting signs of life on such distant worlds has always been an immense challenge, until now. The James Webb Space Telescope, launched in December 2021, has proven to be an extraordinary tool for deep space exploration. Orbiting the Sun approximately 1 million miles from Earth, the JWST is positioned at a location known as the Second Lagrange Point, L2, where it can remain stable and unobstructed by Earth's shadow. This unique vantage point gives the JWST the ability to capture highly detailed observations of distant celestial bodies, far surpassing what previous telescopes could achieve. The JWST is equipped with some of the most advanced technology ever deployed in space. One of its key features is its ability to observe in infrared light. Unlike visible light, infrared wavelengths can penetrate cosmic dust and reveal features that would otherwise be hidden from view. This is especially useful when studying exoplanets like Proxima Centauri b, as infrared light helps scientists peer through the layers of its atmosphere and detect subtle chemical signatures. This ability to observe in the infrared spectrum is what makes the JWST particularly effective at searching for signs of life, such as the detection of gases like carbon dioxide, methane, and water vapor, key indicators that suggest the possibility of habitability. In addition to its ability to analyze exoplanet atmospheres, the JWST is capable of detecting extremely faint light. This is particularly important when studying distant planets like Proxima Centauri b, as any potential signals, whether natural or artificial, are likely to be incredibly weak due to the vast distances involved. Yet, the JWST sensitivity allows it to pick up even the faintest light sources, making it an ideal tool for investigating the mysterious city-like lights observed on Proxima Centauri b. Whether these lights are of natural origin or represent artificial illumination created by an intelligent civilization remains to be determined. However, the very possibility has sent waves of excitement across the globe. If these lights turn out to be artificial, they would provide the first direct evidence of an advanced extraterrestrial civilization. For decades, scientists have speculated about the existence of intelligent life beyond Earth, but concrete evidence has been elusive. Radio signals, like those sought by the Search for Extraterrestrial Intelligence (SETI) program, have long been considered a possible means of detecting alien civilizations. However, so far, no definitive signals have been detected. The discovery of artificial lights on a distant exoplanet would shift the paradigm entirely. Unlike radio waves, which can travel vast distances across space, lights emitted from a planet suggest the possibility of a society actively generating energy, whether through technology or infrastructure like cities. The implications of such a discovery would be profound. Not only would it confirm that intelligent life exists elsewhere in the universe, but it would also open up new avenues for understanding the development of civilizations beyond Earth. How advanced is this potential society? What kind of technology do they possess? Are they aware of our existence? These are just a few of the questions that scientists and researchers would seek to answer in the wake of such a monumental find. However, even if the lights on Proxima Centauri b turn out to be natural phenomena, the fact that the JWST was able to detect them from such a great distance is still a significant achievement. It demonstrates the power of modern space exploration technology and the potential for future discoveries that could one day answer humanity's most profound question: are we alone in the universe? Whether or not intelligent life exists on Proxima Centauri b, the quest to explore our cosmic neighbors and uncover the mysteries of distant worlds continues. The James Webb Space Telescope's capabilities are already reshaping how we study the universe, paving the way for new, groundbreaking discoveries. As we look toward the future, the quest to understand whether we are alone in the universe remains one of the most profound and exciting scientific endeavors of our time. The discovery of potential city-like lights on Proxima Centauri b may represent just the beginning of a new era in space exploration, one that could lead to humanity's first contact with an extraterrestrial civilization. But before scientists jump to conclusions, there's still much work to be done. Investigating these lights further, through future observations and more advanced technology, will be essential in confirming their nature and origin. Are these lights merely a natural occurrence, or is there something more to this discovery than meets the eye? Proxima Centauri b's position in the habitable zone means that conditions for life could be possible. However, life as we know it on Earth depends on several key factors, including a stable atmosphere, liquid water, and a source of energy. If any of these factors are absent, it becomes far less likely that the planet can support life. Furthermore, even if life does exist on Proxima Centauri b, it could be vastly different from anything we've ever imagined. Evolution may have taken a completely different path on this distant planet, producing life forms that are radically different from those on Earth. Understanding the full implications of this possibility would require an open mind and a willingness to challenge our preconceived notions about life beyond Earth. One critical step in this process will be to continue refining the techniques and tools that allow us to observe distant planets. The James Webb Space Telescope's extraordinary sensitivity to infrared light is just the beginning. As new, even more powerful telescopes are developed, we'll be able to gather more detailed data about Proxima Centauri b and other exoplanets like it. In particular, the upcoming Extremely Large Telescope, ELT, which is currently under construction in Chile, is expected to revolutionize the field of exoplanet exploration. With a primary mirror measuring 39 meters in diameter, the ELT will be the largest optical-to-infrared telescope in the world when it becomes operational in the late 2020s. Its unprecedented resolution will allow scientists to study the atmospheres of distant planets in greater detail than ever before. But even as we push the boundaries of our technological capabilities, we must remain cautious and critical in interpreting our findings. The search for extraterrestrial life is a complex and highly challenging field, and the possibility of false positives is always present. What may initially appear to be signs of life could, in fact, have entirely natural explanations. The search for extraterrestrial intelligence is no longer confined to the realms of science fiction. It is now a legitimate scientific endeavor, supported by some of the most advanced instruments ever built by humanity. The James Webb Space Telescope is at the forefront of this effort, and its early observations of Proxima Centauri b may one day be remembered as a pivotal moment in the history of space exploration. The mystery of the lights on Proxima Centauri b and the general public alike. While the true nature of these lights remains uncertain, their discovery has reignited the hope that one day we may find definitive proof of life beyond Earth. The search for life on Proxima Centauri b and beyond is not just about answering the question of whether we are alone. It's about expanding the boundaries of human knowledge, pushing the limits of what we can achieve, and deepening our understanding of the universe and our place within it. Whether or not we find intelligent life, the exploration itself is a testament to humanity's unyielding curiosity and drive to explore the unknown.
The Big Bang Theory, once the cornerstone of modern cosmology, has faced increasing scrutiny with the advent of groundbreaking new information from the James Webb Space Telescope. This remarkable instrument has made a surprising discovery that is currently revolutionizing our understanding of the universe and the fundamental principles of physics. The recent image captured by this advanced telescope has generated compelling arguments that have left experts astonished, effectively bringing an end to much of the speculation surrounding the origins and mechanics of the cosmos. The discovery, not only visually stunning but also deeply transformative, has the potential to change how we perceive the universe. The intense discussions sparked among experts focus on what this image reveals about the structure and nature of the cosmos. It challenges long-held beliefs about how the universe behaves, particularly concerning one of the most pressing questions in astrophysics, the age of the universe and the rate at which it expands. For generations, scientists have grappled with this complex issue, conducting numerous studies in an effort to answer the unresolved questions. Cosmologists have long been driven by the quest to understand the universe's origins, its inner workings, how it has evolved over time, and ultimately, how it might end. Significant progress has been made in the field over the past century, but the universe still holds many mysteries. The Big Bang Theory, widely accepted as the leading explanation for the universe's creation, proposes that the universe has been expanding for approximately 13.8 billion years, originating from a state of extreme heat and density. A critical factor in measuring this expansion is the Hubble constant, a value that reflects the rate at which the universe is growing. However, determining how to measure the Hubble constant is far from straightforward. Scientists use two primary methods to estimate this rate: local measurements, which observe stars and other celestial objects nearby, and measurements of the early universe, which rely on data from deep space. For instance, objects like stars and Type 1a supernovae are considered standard candles in astronomy due to their consistent brightness. By measuring their distance, astronomers can calculate the Hubble constant and, in turn, gauge how fast the universe is expanding. One method involves studying the early universe through the cosmic microwave background (CMB) radiation, a faint afterglow from the Big Bang itself, discovered in the 1960s. This radiation dates back to when the universe was just 380,000 years old, a mere fraction of its current age. By analyzing the tiny fluctuations in temperature and polarization in the CMB, scientists can estimate the universe's age and its expansion rate. However, there's a significant issue: the two methods, local measurements and CMB data, do not produce the same results. Local measurements suggest the universe is expanding faster than what the CMB data indicates, leading to what has been dubbed the Hubble tension. The discrepancies between these two methods have perplexed scientists, prompting further research and debate. Scientists have been working diligently to understand the reasons behind these differences, as they could point to deeper, unresolved mysteries about the universe's nature. The data provided by the James Webb Space Telescope, which allows astronomers to look farther into the universe than ever before, was expected to help resolve this issue. Yet, surprisingly, the first batch of data from this telescope has revealed anomalies that don't align with existing theories and expectations. These findings raise more questions than answers, prompting some experts to wonder if this new information might force us to rethink what we thought we knew about how the universe operates. There is even speculation that the latest discoveries could unveil previously unknown particles or forces, expanding our understanding of the fundamental components of reality. One of the biggest challenges in modern cosmology is the mystery of dark energy, an enigmatic force that accelerates the universe's expansion. Scientists have theorized that this force plays a crucial role in shaping the universe's fate, but its true nature remains elusive. Every new discovery in this field adds another layer of complexity to our understanding. For example, when the cosmic microwave background radiation was first detected in 1965, it provided critical support for the Big Bang theory. Before this, scientists believed the universe would expand at a steady rate indefinitely, but new evidence revealed that this was not the case. In the late 1990s, researchers made a revolutionary discovery: the universe's expansion is not slowing down as once thought, but is instead accelerating. This led to the recognition of dark energy as a driving force behind this acceleration. Each breakthrough forces cosmologists to reassess previous knowledge, ultimately leading to new ways of understanding the universe. Without these ongoing challenges, cosmology would stagnate. The complexity of these problems, while daunting, also excites scientists as it pushes the boundaries of human knowledge and drives the development of more sophisticated tools to explore space. The unresolved Hubble tension highlights just how much we have yet to learn about the universe. Despite the complexities involved, scientists from all over the world are eager to study this cosmological puzzle. Understanding the universe's expansion rate and other fundamental aspects of its structure could unlock profound insights into the cosmos. One important concept closely tied to the Hubble tension is that of matter distribution across the universe. Some areas of space contain dense clusters of galaxies, while others are relatively empty. Scientists use various methods to determine the degree of this uneven distribution. One such method involves gravitational lensing, a phenomenon where the gravity of dense matter, like galaxy clusters, bends light from distant galaxies. This allows astronomers to map the distribution of dark matter, a form of matter that doesn't emit light and remains invisible but has a profound effect on the universe's structure. Additionally, scientists continue to study the cosmic microwave background, the afterglow of the Big Bang, which has been traveling across the universe for 13.8 billion years. This ancient light provides valuable clues about the universe's early days, revealing that it was once filled with tiny irregularities. However, a troubling issue arises when comparing this data to current observations. The large-scale irregularities observed today, such as the uneven distribution of galaxies, do not match the predictions from the early universe. This discrepancy suggests that there might be something missing in our understanding, potentially involving dark matter, dark energy, or other phenomena yet to be discovered. One notable researcher, Ray, and his team have been re-examining these issues with the help of the James Webb Space Telescope. They sought to determine if errors in the Hubble Space Telescope's measurements could explain the inconsistencies, but the new telescope confirmed the same troubling deviations. This raises concerns that there may be a fundamental flaw in our understanding of the universe. In a recent interview with an astronomical magazine in the United States, Ray emphasized the importance of the Webb Space Telescope's sharp infrared imaging capabilities, which allows scientists to observe the universe's most distant objects with unprecedented precision. These observations are crucial for studying cosmic distances and refining measurements of the universe's expansion rate. Both dark matter and dark energy remain enigmatic components of the cosmos, accounting for a significant portion of the universe's mass and energy. Despite their influence, their true nature continues to elude scientists. While black holes have been the leading explanation for certain gravitational phenomena, there is growing interest in exploring how dark matter and dark energy might play a role in these cosmic effects. As researchers continue to unravel these mysteries, they push the limits of human knowledge, demonstrating how science constantly evolves as we uncover more about the universe. As we delve deeper into the mysteries of space, our understanding of the universe will undoubtedly continue to evolve, just as it has throughout history. Whether it's through new technologies like the James Webb Space Telescope or through refined theories and models, each discovery builds upon the last. Science thrives on the challenges posed by the unknown, and cosmology is no exception. With every new finding, we are forced to confront our assumptions and consider new possibilities, ensuring that our journey to understand the cosmos remains as exciting
or inspiring it with mystery and human. Earth is a teeny array. It is scale. The vastness of space stretches beyond our wildest imagination, and our place in it seems minuscule in comparison. Yet, humanity's innate curiosity has always driven us to explore and understand the unknown, to reach out beyond our home planet and discover what lies out there in the cosmos. The advent of advanced technology, especially over the last century, has allowed humans to send spacecraft, rockets, and satellites into space, fueling a never-ending desire to uncover the secrets of the universe. This technological leap has sparked an insatiable curiosity to delve into the unknown, pushing the boundaries of our scientific knowledge. While we have made tremendous progress in understanding the universe's workings, much of what we know is still based on theories, hypotheses, and assumptions. Although scientists have developed reasonable explanations for many cosmic phenomena, much of our knowledge remains incomplete. This is where the Voyager 1 and Voyager 2 space probes come into play. These remarkable spacecraft have been instrumental in expanding our understanding of the universe and its distant reaches. Launched in the late 1970s, these probes have ventured far beyond the familiar realms of our solar system, traveling into the unknown and sending back invaluable real-time data. Their findings have enlightened us about the farthest corners of our solar system and even ventured into the unexplored territories of interstellar space. These are places that humans may not physically visit for generations, if at all, but the Voyagers are our eyes and ears in these distant regions. But as we uncover more about the cosmos, sometimes the data we receive carries unsettling implications. What happens when the information these probes send back contains disturbing warnings or revelations that challenge everything we thought we knew about the universe? What if the very fabric of our understanding is questioned? Join us as we take an in-depth look at the discoveries made by the Voyager missions, particularly Voyager 1, and the alarming messages it has conveyed about the future of space exploration and our place in the universe. For nearly half a century, the Voyager missions have led the charge in space exploration. These twin spacecraft have provided scientists with a treasure trove of data, offering insights into the mysteries of our solar system and the broader universe. The sheer duration of these missions is nothing short of remarkable, considering they were initially designed to last only 5 years. Yet, they continue to operate, far outliving their expected lifespans, and providing an enormous amount of data along the way. The history of the Voyager program is captivating in its own right. It began with the accidental discovery by a young NASA scientist, Michael Minovich, who realized that a spacecraft could use a planet's gravitational pull to slingshot itself further into space. This revolutionary concept allowed the spacecraft to travel much farther than previously thought possible, setting the stage for the launch of the Voyager missions. In 1977, Voyager 1 and Voyager 2 were launched, their primary mission to study the gas giants Jupiter and Saturn. These two planets had long been of great interest to scientists, with their immense size, complex atmospheres, and numerous moons. What the Voyagers accomplished, however, exceeded all expectations. Both spacecraft are equipped with 3.5-meter parabolic antennas that communicate with Earth, along with 16 thrusters to adjust their orientation and ensure their antennas remain pointed toward our planet. Their engines run on hydrazine fuel, and their onboard electronics are powered by thermoelectric generators, fueled by plutonium. In addition to these remarkable features, each probe carried 11 scientific instruments. These tools were designed to study the planets they encountered, from analyzing atmospheric conditions to examining magnetic fields. Over time, as the probes moved further from their original targets, some of these instruments were shut down, but many continue to function, sending back valuable data. One of the most ambitious parts of the Voyager missions was the so-called Grand Tour of the Outer Planets. This tour became one of the greatest achievements in the history of space exploration. Voyager 2, in particular, achieved the distinction of being the first spacecraft to closely observe Uranus in 1986 and Neptune in 1989. These encounters provided scientists with unprecedented views of these distant planets and their moons. Voyager 1, which had overtaken Voyager 2 just a few months after its launch, conducted flybys of Jupiter in 1979 and Saturn in 1980. These encounters made Voyager 1 the most distant man-made object from Earth, a title it still holds to this day. Despite the immense distances both probes have traveled, they continue to operate, with Voyager 2 currently functioning with 5 active instruments, while Voyager 1 has 4. Together, these probes are still gathering valuable information about the outermost regions of the solar system and the vastness of interstellar space beyond. As both spacecraft venture farther from the Sun's influence and into interstellar space, they continue to send back crucial data about the cosmic environment they encounter. This data is helping scientists piece together a better understanding of the space between stars, a region that had remained largely unexplored until now. But before we dive into the mysterious messages Voyager 1 has sent back, let's take a moment to appreciate the profound discoveries these two missions have made along the way. Imagine embarking on an epic voyage to explore the unknown regions of our solar system, with Voyager 1 and Voyager 2 as your companions. Their first mission was to take a detailed look at the majestic Jupiter and Saturn systems, and they succeeded beyond anyone's expectations. The images and data sent back by the Voyagers transformed our understanding of these gas giants. They revealed the intricate cloud patterns and turbulent weather systems of Jupiter, including its iconic Great Red Spot, a massive storm that has raged for centuries. The probes also provided new insights into Saturn's complex ring system, capturing stunningly detailed images that allowed scientists to study its composition and structure like never before. As Voyager 1 moved beyond Saturn and out of the solar system, Voyager 2 still had exciting targets ahead. In 1981, a carefully planned maneuver adjusted its course, setting it on a path toward Uranus. By 1986, long past its expected lifetime, Voyager 2 arrived at Uranus, where it made one of its most significant discoveries. The probe identified 10 previously unknown moons, expanding our knowledge of Uranus's satellite system. These moons had gone undetected by earlier telescopes, but Voyager 2's instruments captured their presence, adding them to the growing list of Uranus's known companions. Yet, the journey didn't end at Uranus. Voyager 2 pressed onward toward Neptune, its final planetary destination. In 1989, it sent back more than 9,000 images of Neptune and its moons, leading to the astonishing discovery of 9 new moons. Among these, Triton, Neptune's largest moon, revealed secrets that astounded scientists. Its diameter turned out to be different than previously thought, and it had surprisingly few craters for a moon of its size. More intriguingly, Voyager 2's data revealed that Triton's whitish-brown color was due to geysers spewing liquid nitrogen, which froze upon contact with the surface, creating a landscape of nitrogen snow. The Voyager missions left an indelible mark on our understanding of the solar system's outer planets. No other probe has since returned to Uranus or Neptune, and scientists continue to study the data collected during those historic flybys. The discoveries made by Voyager 2 at Uranus and Neptune have spurred ongoing interest in these icy giants, prompting further investigation by scientists around the world. Uranus, one of the lesser-known planets in our solar system, is classified as an ice giant, along with its neighbor Neptune. Despite the cold connotations of its name, much of Uranus is not frozen. Instead, the planet consists primarily of supercritical fluids, high-temperature, high-pressure substances that combine the properties of liquids and gases. Uranus is located about 1.8 billion kilometers from the Sun, making it the second most distant planet in the solar system. With a diameter over 4 times that of Earth, it is an immense planet. Yet, one of its most curious characteristics is its sideways rotation. Unlike most planets, which rotate in an upright position relative to Uranus rotates on its side. Scientists speculate that a massive collision with a protoplanet in the distant past may have caused this unusual tilt. This event might also explain the presence of the 27 moons that orbit Uranus, possibly formed from the debris of the impact. Even more fascinating, about a decade ago, the Hubble Space Telescope detected a massive storm in Uranus's atmosphere, a gigantic white spot with winds reaching up to 143 km per hour. In addition to these violent weather systems, Uranus is home to frigid clouds composed of methane and ammonia, where temperatures can plummet to -197 degrees Celsius. While less prominent than Saturn's, Uranus also has a faint ring system, composed of dark, dispersed material. Neptune, discovered in 1846, holds the title of the most distant planet in our solar system. Located nearly 5 billion kilometers from the Sun, it exists in near-total isolation, far removed from the warmth and light of the inner solar system. To put its distance in perspective, the Earth is only 150 million kilometers from the Sun, while Neptune is more than 30 times that distance. Despite its remoteness, Neptune shares many similarities with its neighbor Uranus, including its size. With a diameter of roughly 50,000 kilometers, Neptune is comparable to Uranus in scale. However, it takes much longer to complete an orbit around the Sun, 165 years to be exact, while it spins on its axis rapidly, completing a full rotation in just 16 hours. When Voyager 2 visited Neptune in 1989, it observed extreme weather phenomena, including bright cloud bands and massive storms with winds reaching speeds of 2,100 km per hour, the fastest ever recorded in our solar system. Scientists believe that the low levels of solar energy reaching Neptune might allow these storms to reach such incredible velocities. However, these storms are not permanent, they may eventually dissipate or disappear. One of the most famous features Voyager 2 observed was the Great Dark Spot, a massive storm system similar to Jupiter's Great Red Spot. But when astronomers attempted to locate the Great Dark Spot a few years later, it had vanished without a trace. Some scientists theorize that internal heat from Neptune's core caused atmospheric turbulence that led to the storm's disappearance. Neptune's core remains one of the great mysteries of planetary science. Despite the planet's turbulent atmosphere, scientists estimate that its core is composed of rock and metal, with a mass between 1 and 1.5 times that of Earth. Temperatures within Neptune's core are thought to soar to nearly 13,000 degrees Fahrenheit, and pressures can reach several million bars. Both Uranus and Neptune also have highly unusual magnetic fields, which have long puzzled scientists. Unlike Earth, where the magnetic field is closely aligned with the planet's rotational axis, the magnetic fields of Uranus and Neptune are significantly tilted, adding to the mystery surrounding these distant giants. Now, as the Voyager missions push further into interstellar space, they continue to send back data that challenges our understanding of the universe. Voyager 1 has crossed into the region beyond the Sun's influence, where it has encountered surprising phenomena, including the detection of strange, unexplained signals. These signals, combined with data from Voyager 2, raise important questions about the nature of interstellar space and the future of space exploration. As we analyze the disturbing messages sent back by the Voyager probes, we are reminded that the universe is far more complex and mysterious than we once believed. Let me know what you think in the comments section. If you enjoyed this deep dive into the Voyager missions and the incredible discoveries they've made, be sure to like the video and subscribe for more space exploration content.
Have you ever wondered what mysteries are hidden in the vast cosmos? Renowned American physicist Mish Gaku has made a discovery that promises to change everything. And this discovery has been made possible by the legendary Betelgeuse. This device has revealed something truly revolutionary. The times, as we understand them, do not exist. It is about to embark on a space-time conundrum that will shake your perception of the world. The Webb telescope is unlocking secrets from the farthest corners of the universe, thanks to its advanced infrared technology, becoming the ultimate time machine for exploring the past. Join us on this journey to discover how this telescope has changed conventional theories, redefining our understanding of time as we know it. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Have you ever wondered how the amazing resolution and sensitivity of the James Webb Space Telescope make it possible to identify objects of extreme age and distance, even beyond Hubble's capability? We are referring to distant galaxies and celestial bodies of the early universe. Those elusive entities that have been playing an epic cosmic game of hide and seek. In short, the James Webb Telescope is assisting us in painstakingly reconstructing the immense stellar history of the universe piece by piece through its exceptional detection capabilities in the infrared spectrum. Imagine yourself in an art gallery, browsing through immense works captured by the James Webb Space Telescope. These images are breathtaking, with distant galaxies glowing on the cosmic canvas. Among astronomers and cosmologists, however, there is a sense of amazement. The common expression heard is that this is totally unexpected. We have just shaken the foundations of their understanding of the universe. Although official reports have not divulged much about it, the real challenge lies in a previously accepted theory, the Big Bang Theory. The assumption being challenged is the idea that our universe originated through a massive explosion some 13.8 billion years ago and has been expanding like a giant balloon ever since. This theory has been central to our understanding of cosmology for decades. However, new observations made by the James Webb Space Telescope have cast uncertainty on its validity, generating an uproar in the scientific community. We can almost imagine Allison Kirkpatrick, a senior astronomer at the University of Kansas, questioning her entire career as she lies in bed. Why so much surprise? The reason for this bewilderment lies in the fact that galaxies captured by the James Webb do not behave according to what the Big Bang hypothesis would predict. They are too small, excessively uniform, and appear to be of an age incompatible with this theory. Moreover, their numbers are surprisingly high. To simplify these discrepancies, we imagine the universe as an expanding globe. According to conventional theory, galaxies should not appear smaller as they move away from us. At a certain point, they should begin to appear larger, since their light would have had to travel from when they were closer. This unusual but crucial shift in the conceptions of an expanding universe is evident in the James Webb images, where galaxies appear to maintain a similar size to those closer to us. In reality, the conventional theory may be making several mistakes. Surprising as it may seem, recent research has indicated that the Big Bang Theory is an error in 16 of its predictions, which is a significant number. The only prediction that has been accurately verified concerns the abundance of deuterium, a type of hydrogen, but that is only the beginning. The theory we have long relied on has also been predicting twice the amount of helium and 20 times the amount of lithium that we actually find in the universe. In addition, the Big Bang Theory faces challenges in attempting to explain the enormous structures observed in the cosmos. According to this theory, these structures are simply too large to have formed in the time since the beginning of the universe. Furthermore, the theory has difficulties in trying to predict the density of matter in the universe. And here comes an interesting surprise. Those supposed asymmetries that were thought not to exist in the cosmic microwave background actually turn out to be real. This adds an unexpected twist to the cosmic narrative. All this leads us to the James Webb Space Telescope, an amazing technological feat that may hold the answers to these cosmic contradictions. These discrepancies may seem like minor details in the vast panorama of cosmic knowledge we have accumulated, but it's important to note that they are far from insignificant. Each small error amounts to a missing piece of our cosmic puzzle, preventing the creation of a complete picture of the nature of the universe. These abnormalities raise significant questions about everything we thought we knew about the origin and development of the universe. They challenge our understanding of cosmic structures and the very structure of space-time, which has a fundamental impact on our understanding of universal expansion, gravitational waves, dark matter, and even the ultimate fate of the universe. For example, if the density of matter turns out to be variable, this would modify our conception of how galaxies are created and developed, as well as our approach to the role of dark matter in this whole process. Similarly, unexpected discrepancies in the cosmic microwave background could impact our understanding of the initial conditions of the universe and its expansion. These inconsistencies even have implications for our very understanding of time, as they are closely linked to the evolution of the universe since the Big Bang. If we conclude that the Big Bang Theory is not completely accurate, we would be faced with the need to reevaluate our perception of time, its flow, and its relationship to space. Discoveries of this nature could trigger a paradigm shift in our understanding of space-time, similar to what happened when Einstein presented his theory of relativity. We would be on the threshold of a new understanding of the cosmos, in which it would be necessary to recalibrate our cosmic clocks and redefine our coordinates in the cosmos. Apparently, the universe holds a few surprises in its bosom, don't you think? Have you ever wondered whether time, as we conceive it, is a tangible reality or simply a human construct that we use to discern the past from the present? It is an extremely complex question, but we invite you to join us in its exploration. There's a theory that time could be an illusion generated by our human memories. According to this theory, everything that has happened or will happen is happening right now. It is a truly amazing concept, isn't it? If we delve deeper into this idea, we tend to think of time as something that flows invariably forward. However, here's the intriguing thing. The laws of physics do not require that time works differently whether it moves forward or backward. The Big Crunch theory, for example, suggests that when the universe ceases its expansion and begins to contract, time could move backward as the universe compresses. The temperature will increase, similar to a Big Bang in reverse. Now, what happens after the Big Crunch is a question that has puzzled many of us. Several theorists raise the possibility that a new universe could arise from another Big Bang, while others suggest that our universe could reappear at another point, as if there were a cosmic bubble. There are even hypotheses that the cycle could repeat itself over and over again, giving rise to countless universes. The intriguing idea that time could be bidirectional, that is, that it can flow both forward and backward, has led some scientists to the bold conclusion that time, as we conceive of it, is actually a construct created by humans. They argue that we live in an interconnected space-time, a notion that finds support in Einstein's theory of relativity. Under this premise, all past, present, and future events occupy their respective coordinates in space-time, which unfolds in 4 dimensions. So what does this imply for us? In essence, it suggests that everything has a reality as solid as the present moment, and that the past and the future exist somehow, somewhere in space-time. MIT physicist Max Tegmark expressed this concept eloquently by describing that we see our reality as a three-dimensional space where events occur in time. But in reality, it is a four-dimensional space where everything just is. If this approach were true, then time would be revealed as an illusion, since nothing would undergo real change. Past, present, and future would coexist. These ideas are profound and challenging, but they are fascinating to ponder, as they illustrate how magical and enigmatic the universe can be. Julian Barber, a British physicist, provides a unique perspective on time in our universe. His argument is based on the notion that reality is made up of a succession of discrete moments comparable to individual photographs in an album, with each image representing a unique instant. For Barber, our perception of the past is reduced to a construct that relies on the memory stored in our brains, raising the possibility that the notion of the past is, in essence, an illusion. Barber addresses this idea throughout the theories of space, in which each moment exists in a place within a vast landscape that he calls Plutonia. In Plutonia, each point represents a present, and this landscape is governed by precise mathematical rules that make it intrinsically timeless. This perspective is related to the renowned name of Albert Einstein, whose theory of spacetime is fundamental to our current understanding of the universe. However, the implications of this theory and our understanding of it have raised significant questions. If Einstein's concept of spacetime were to be proven incorrect at some point in time, would it be necessary to discard it altogether in pursuit of a more accurate understanding of the universe? We invite you to reflect on this question. Share your opinions in the comments. If you found the content interesting, don't forget to express your support by liking, subscribing to the channel, and activating notifications to receive future content. Thank you so much for watching the video, and see you in the next one.
If you go to the early universe right after the Big Bang, it was expanding way faster than the speed of light. Just like how CERN has presented the heliocentric model, we may be in for another mind-blowing revision to our cosmic understanding. A debate has arisen in cosmology known as the crisis of cosmology. Neil deGrasse Tyson has said that the James Webb findings have ended this debate in a physics-shattering image. So, what exactly is this crisis, and how has the James Webb Space Telescope contributed to it? For some, it's hard to call it a crisis. It is a crisis, but for some old-timers, it's really hard. There was a time when we didn't know the age or size of the universe because they are related within a factor of 2. Join us as we venture into the very frontier of science, where our knowledge is constantly put into question and where we're making unanticipated discoveries. Over the past century, a significant achievement in cosmology has been the establishment of a standard model outlining the universe's history and its current state. Gravity, guided by general relativity, primarily dictates the universe's evolution, explaining both its expansion and the formation of large cosmic structures. The known components include dark energy, dark matter, normal matter, neutrinos, and photons. The universe originated from the hot Big Bang around 13.8 billion years ago, preceded by cosmic inflation, which caused density imperfections. But what if we told you that this very model is now under scrutiny? This model has been responsible for our understanding of the universe for the past century or so. Despite extensive observational support, this model might be incomplete. While we're getting more and more observations, each new one has to be examined in the context of the model to see if it still holds up. But astronomers have gotten a new tool in their toolset with the JWST, and this device has been creating problems for our standard model. It all started in the early universe before stars or galaxies emerged, when neutral atoms were forming around 380,000 years post-Big Bang. Then, 550 million years later, reionization occurred, ionizing most of the universe. The initial waves of reionization started approximately 200 million years after the Big Bang, with some stars possibly forming 50 to 100 million years after. The JWST, with its capabilities, allows astronomers to unveil more distant galaxies than previously possible, offering new insights into the early universe. First, let's go through what we know. The standard model of cosmology, known as the inflationary hot Big Bang or lambda CDM, has been remarkably successful. It explains various features of the universe, including gravitational lensing, the cosmic web structure and growth, the internal motions of galaxies, their relative movements within groups and clusters, and features in the cosmic microwave background. This model predicts that as we look further back in time and cosmic distances increase, the observed galaxies should be inherently smaller, bluer, less developed, and less rich in heavy elements. At some point beyond our current observational reach, we anticipate entering the universe's dark ages, devoid of visibilities. But while verifying the integrity of these explanations, scientists have found conflicting evidence, resulting in a crisis of cosmology. The cosmology crisis is simple: we don't really know the age of the universe. Different methods give different results, and it's up to cosmologists to find out why, but they're struggling to do so. Let's take a look at the methods we use to measure the universe's age. The first one is cosmic background radiation. To unravel this cosmic mystery, scientists delve into the universe's expansion history, and to do that, they need mathematical modeling. This modeling is based on Einstein's general relativity theory. Applying this theory to the entire universe produces the Friedmann equations, linking the universe's composition, dark matter, dark energy, radiation, and more with its expansion rate at specific times. By measuring these contents, we can get the age of the universe using the cosmic microwave background CMB to do just that. The CMB is the remaining light from the early days of the universe when it was about 380,000 years old. It is a crucial tool in measuring the universe's contents. Exceptionally detailed maps of the CMB provide insights into the universe's composition. One such map is from the European Space Agency's Planck mission. But there's an issue with these maps: they lack data on dark energy, which is a significant player in the current universe. Dark energy didn't influence the early universe, so scientists must incorporate its effects manually based on other observations. Despite this, scientists can use the Friedmann equations to figure out the expansion rate of the universe at any point in time. They can even figure out the expansion rate today, and through that, determine the age of the universe. Another way to measure the age of the universe is by looking at exploding stars. While the CMB provides a thorough record of the universe's makeup, it's a historical snapshot originating billions of years ago. Another way to measure the universe's expansion is by directly observing its rate of growth. Thanks to Type Ia supernovae, a celestial spectacle where a star dumps its atmosphere onto a nearby white dwarf, the remnants of a deceased star. When the white dwarf hits a critical mass, it erupts into a supernova. Since this cosmic drama unfolds similarly across the universe, scientists consider supernovae consistent benchmarks or standard candles. This means we know their expected brightness, and by comparing it to their observed brightness, we can estimate the universe's expansion rate at the time of the supernova. This method, employed in the late 1990s, played a pivotal role in discovering dark energy, becoming a cornerstone in cosmological measurements. The JWST has complicated things further. According to Neil deGrasse Tyson, the JWST has found things that, to our current understanding of the universe, shouldn't exist. Something had to change. Our current scientific understanding needs to be reworked, but we simply have no idea where to start. For instance, the JWST's recent images reveal galaxies much more distant and consequently older than anticipated by the standard cosmological model. This is yet another piece of evidence suggesting that our model needs updating. Hubble's groundbreaking revelation of the expanding universe relied on galaxies, and the JWST's images showcasing galaxies forming much earlier than current cosmological models predict have sparked a crisis in the field. So, how do we explain such a discrepancy? One solution proposes flaws in our CMB measurements, yet the Planck CMB measurements, among the most precise in science, have undergone extensive testing since their 2013 release, validating their accuracy. An alternative perspective suggests a potential gap in our understanding of dark energy. Perhaps dark energy varies over time, intertwines with dark matter, or involves another unknown factor. This possibility captivates theorists, sparking numerous exploratory papers. Lastly, the accuracy of supernova measurements could be questioned. Although more directly gauging the present expansion rate, supernova observations are not foolproof due to the complexity of exploding stars. If we don't completely comprehend the intricate physics, supernovae can't serve as a precise cosmological tool. A touch of uncertainty in supernova modeling could resolve the entire discrepancy. In conclusion, the crisis of cosmology remains, leaving scientists puzzled. However, The JWST's discoveries may be the key to unlocking the mysteries of the universe's age, composition, and ultimate fate. An emerging black hole emits ultraviolet radiation into the universe, stripping electrons from hydrogen atoms and enhancing transparency to UV radiation. After successive stellar generations, heavy elements and UV radiation become sufficient, allowing for galaxies to form. Gas quantities and stars collapse into gravitationally bound entities, uniting to form the first galaxies. While observational evidence supports key aspects of this narrative, challenges arise when integrating it into the cosmological framework of the expanding universe. The standard cosmological model establishes a link between observed distances expressed through redshift and the age relative to the Big Bang expressed in years. Distances are directly observed and are unchangeable values, while age emerges from theoretical constructs melding models of an expanding universe, guided by Einstein's general relativity and our comprehension of matter from the standard model of particle physics. Together, they explain how distance or redshift correlates with age, the duration since the Big Bang. The issue arose when the James Webb Space Telescope started operating. As soon as it started looking at distant galaxies, it found things that betrayed our current knowledge. It found galaxies much more distant and older than predicted by the standard model. The Hubble telescope had already hinted at this, but the JWST confirmed it. While the universe originated from the Big Bang, indicating its beginning, discrepancies emerge in the apparent age of the first galaxies compared to the age redshift relations predictions. These galaxies seem to appear too early, which is impossible according to our current understanding. The foundational Big Bang model, depicting an evolving universe rather than a static, unchanging one, remains unchallenged, but there might be a need to update our understanding. Increasing evidence in the form of data keeps making us question this story. But how much needs to be changed, and what are scientists doing to get to the bottom of this? Scientists are turning towards even better equipment to answer these complex puzzles. One such venture is a project known as Flamingo. The Flamingo Project, part of the Virgo Consortium, engages in extensive computer simulations spanning from the Big Bang to the present to explore the universe's evolution. This program investigates the elements of the cosmos. Funding for this project was secured from the European Research Council, the UK's Science and Technology Facilities Council, the Netherlands Organization for Scientific Research, and the Swiss National Science Foundation. Throughout the simulations, detailed virtual galaxies and galaxy clusters emerge. Telescopes like the Euclid Space Telescope and NASA's James Webb Space Telescope gather data on celestial entities. The simulations will be compared to the observed data, letting us know how accurate the standard cosmological model is and if it really explains the universe's evolution to a good extent. Professor Carlos Frank, a collaborator in the Flamingo research and Ogden Professor of Fundamental Physics at Durham University, notes a pivotal moment in cosmology. He says that cosmology is at a crossroads. New telescopes are very accurate, and the information we get from them doesn't align perfectly with our theoretical models, which in turn raises questions about the validity of these models or potential biases. The precise simulations aim to discern whether these discrepancies challenge the existing cosmological framework. Previous simulations primarily focused on cold dark matter. However, astronomers now emphasize the inclusion of ordinary matter, constituting only 16% of the universe, and neutrinos when comprehending the universe's evolution. Neutrinos are minuscule, infrequently interacting particles. Led by Professor Jup Shea from Leiden University, researchers conducted extensive simulations to investigate the universe's evolution.
Well, today we're going to talk about one of the great instruments of science, the Voyager spacecraft.
This is the one that's traveled farthest from home, Voyager 1. She bears a message to 1 billion years from now. Although Voyager 1 has been exploring the cosmos for over 45 years, it hasn't seen it all. It keeps uncovering something new every day, and its recent discovery, validated by Neil deGrasse Tyson, remains a mystery to the scientific world. The spacecraft just detected the existence of 775 celestial objects while exploring interstellar space. Are these mysterious celestial objects real, or are they the result of inaccurate data transmission from Voyager 1 to NASA? Could they be the handiwork of extraterrestrials? Join us in this video as we explore how Voyager 1 recently detected 775 unknown objects passing by in space. Neil deGrasse Tyson is a familiar face in the scientific community, which he officially joined when he gained admission to study physics at Harvard University. An astrophysicist, author, and science communicator, Tyson has been an advocate for expanding the operations of NASA. He believes that NASA is underfunded to effectively execute the work that needs to be done. Besides speaking up for more funding for NASA, Neil deGrasse Tyson has never shied away from conversations on what transpired in the universe long before we came around. He also believes that there is still a whole lot we don't know about the universe we live in, and it's only fair that we explore them. This explains why Tyson's interest was piqued recently when Voyager 1 detected 775 unknown objects passing by in space. Mother Earth is a remarkable planet with several mind-blowing features, but compared to the rest of the universe, it is just a mere speck. Philosophers have known this for several centuries, but they didn't have a chance to prove this statement until NASA scientists came along with a spectacular invention in the 70s. However, this invention might not have come into existence if not for the alignment of the stars, which, in the real sense, are the four largest planets of our solar system. The alignment of the four planets had largely been unnoticed until it got the attention of Gary Flandreau, a Ph.D., student at the California Institute of Technology. Flandreau, who was working part-time at NASA's Jet Propulsion Laboratory, charted the orbital paths for the giant planets Jupiter, Saturn, Uranus, and Neptune. When doing this, he stumbled upon something amazing. He found out that in the late 1970s and early 1980s, all four planets would be strung like pearls on a celestial necklace in a long arc with the Earth. This discovery excited Flandreau's superiors at NASA because he had been tasked with finding out the most efficient way to send a space probe to Jupiter and the other giant planets. Back to this rare event that had unfolded in the eyes of NASA scientists, it meant that a space vehicle could get a speed boost from the gravitational pull of each giant planet passed. It would be as if it was being tugged by an invisible cord that snapped at the last second, flinging the probe on its way. From Flandreau's calculations, it was estimated that the repeated gravity assists from the planets would cut the flight time between Earth and Neptune from 30 years to 12 years. However, there was one setback to the excitement surrounding this discovery. The alignment occurred once every 176 years. Thus, to reach the planets while the event lasted, a spacecraft would have to be launched in the mid-1970s. This information was passed up the NASA hierarchy, and the space agency decided to seize this once-in-a-lifetime opportunity by developing two spacecraft. These twin spacecraft are known as Voyager 1 and Voyager 2. The spacecraft are twins in every sense because they have identical details. However, they were launched within 15 days of each other in the summer of 1977. Precisely, Voyager 1 was launched into space on September 5th, 1977. The space probe is a part of the Voyager space program, tasked with the mission of exploring the solar system and interstellar space for our benefit. Voyager 1 has been in operation for almost 5 decades and has been communicating with the scientific community through NASA's Deep Space Network. It receives routine commands and transmits the data back to Earth. We are able to monitor the real-time distance and velocity data thanks to NASA and its Jet Propulsion Laboratory. As of August 2023, the space probe was situated 24 billion km away from Earth, making it the most distant man-made object from Earth. The Jet Propulsion Laboratory executed the design and construction of Voyager 1. The probe left our planet from Launch Complex 41 at the Cape Canaveral Air Force Station aboard a Titan III-E launch vehicle. Voyager 1 made its way into space 2 weeks after its twin, Voyager 2, had been launched. NASA launched the probe with the objective of conducting outer planetary heliosphere and interstellar medium exploration. NASA had been very keen on studying what happened or existed between the stars, and the Voyager mission was going to make this dream a reality. Early on in its development, NASA scientists had decided that the spacecraft had to make a flyby over Jupiter, Saturn, and the latter's largest moon, Titan. Although Voyager 1 had been launched later than its twin, it still arrived at Jupiter before Voyager 2. It explored the two gas giants, studying their weather, magnetic fields, and rings. Thanks to Voyager 1, we were able to get detailed images of the moons of Jupiter and Saturn. As mentioned earlier, the Voyager craft mission didn't stop at studying Jupiter and Saturn. The space probe went further to locate and study regions and boundaries of the outer heliosphere. It also extended its operation to include the exploration of the interstellar medium. The spacecraft crossed the heliopause and entered interstellar space on August 25, 2012. Voyager 1 made history by being the first spacecraft to achieve this feat. As the universe would have it, we got confirmation that the Voyager was indeed in interstellar space 2 years later, in 2014. The spacecraft began experiencing a third tsunami wave of coronal mass ejections from the Sun and this continued until December 15th of that year. It was Voyager 1 that gave us the first family portrait of the solar system as seen from outside it. It also provided a famous image of the Earth that was soon nicknamed Pale Blue Dot after exiting the heliosphere. Voyager 1 headed straight for interstellar space. It was time to explore in between the stars. Nevertheless, the instruments of the probe kept studying the solar system. Voyager's mission was expected to end many years ago, but NASA's engineering team seems to have performed their magic on the spacecraft. They have succeeded in extending the spacecraft's mission to 2025. By this period, it is expected that it would no longer have enough electric power to operate its scientific instruments. The team achieved this feat by testing the space probe's trajectory correction maneuver TCM thrusters in late 2017. This was the first time these thrusters had been fired since 1980. The decision to fire the thrusters succeeded in extending the mission's lifespan by 2 to 3 years. One look at the gains achieved by Voyager 1 in the past 4 decades, and it would be hard to believe that the craft's launch almost failed in the summer of 1977. This was because a part of the launch vehicle had shut down prematurely, causing 1,200 pounds of propellant to become unburned. Nevertheless, Voyager 1 is currently traveling at about 523 million km per year, which is about 1 light year per 18,000 years. Speaking of traveling, Voyager 1's high-speed journey would have been a waste of time if it wasn't equipped with the right instruments. The spacecraft has 16 hydrazine thrusters, 3 axis stabilization gyroscopes, and referencing instruments that keep the craft's radial antenna pointed toward Earth. These instruments work together and are part of the Attitude and Articulation Control Subsystem AXEs. The Voyager craft has 8 backup thrusters and is equipped with an additional 11 scientific instruments for studying celestial objects as it explores the cosmos. The scientific instruments include an imaging science system, radio science system, infrared interferometer spectrometer, ultraviolet spectrometer, triaxial fluxgate magnetometer, and plasma spectrometer. The other 5 are low-energy charged particle instrument, cosmic ray system, planetary radio astronomy, photopolarimeter, and plasma wave subsystem. Some of these instruments are active, while the rest are either disabled or defective. NASA engineers designed the radio communication system of the Voyager to be used up to and beyond the limits of the solar system. The communication system consists of a 3.7-meter diameter high-gain antenna to send and receive radio waves via the 3 deep space network stations on Earth. When Voyager 1 is unable to communicate directly with the Earth, it uses its digital tape recorder, DTR. The DTR can record about 67 megabytes of data for transmission at a later time. As of 2023, signals from the Voyager take over 22 hours to reach planet Earth. Additionally, the Voyager was designed with highly sophisticated cameras for capturing images of planets, their moons, and other celestial bodies from a distance. However, the operation of the cameras for visible light is not automatic. Instead, it is controlled by an imaging parameter table contained in one of the onboard digital computers. NASA has since moved on from this design, as succeeding space probes from the 1990s have been equipped with completely autonomous cameras. Voyager 1 has a computer command system, CCS, that controls its cameras. The CCS is equipped with fixed computer programs such as command decoding, fault detection routines, and appointing routines, and spacecraft sequencing routines. The CCS is an upgrade of the one used in the 1970s Viking orbiters. It's been nearly 5 decades since Voyager 1 and its twin, Voyager 2, were launched into space to study the cosmos and bring exciting discoveries to our knowledge. The spacecraft's instruments have been operating consistently over the years by transmitting data back to our planet. One would have expected that this spacecraft, which is located over 14.1 billion miles away from Earth, would have begun to fail. But this is far from the case, as Voyager's computer systems continue to work effectively, capturing and transmitting data back to NASA scientists. We have NASA engineers to thank for the longevity of Voyager 1 in achieving its interstellar mission goals. NASA scientists have been able to sustain the operative capabilities of the Voyager craft through power management and the use of redundant computer subsystems. They have conserved the power of the spacecraft by switching off non-essential systems, ensuring the longevity of the spacecraft. However, it's not just about maintaining the longevity of the equipment, but also ensure that it can successfully process scientific data. If not, they risk losing the prize spacecraft to changing conditions. Over the years, the Voyager spacecraft has been self-powered using radioisotope thermoelectric generators, RTGs. These RTGs, also known as radioisotope power systems, are a type of nuclear battery that uses a thermocouple to convert heat from decaying plutonium into electricity. The generators have no moving parts, which means there's no risk of parts wearing out or malfunctioning. Additionally, they don't need solar energy, making them suitable for remote and harsh environments, such as the outer reaches of the solar system. Despite the advantageous features of the radioisotope power system, the continual decay process means that the generators produce here for Voyager 1's use. Although the dwindling power supply hasn't affected the spacecraft's mission output, NASA engineers took the preemptive step of compensating for the power loss by switching off heaters and other non-essential systems that don't affect the spacecraft's flying capabilities. However, it seems like not only non-essential systems will have to be turned off to keep the craft flying and maintain effective data transmission. Scientists are considering switching off one instrument on the spacecraft, although the decision has not been made yet.
Prepare yourself for a cosmic event of truly cataclysmic proportions, an astronomical disaster the likes of which we have never witnessed before. Betelgeuse, the majestic red supergiant star, is sending ominous signals across the cosmos, and astronomers have made groundbreaking discoveries about this colossal celestial body using the state-of-the-art James Webb Space Telescope. Renowned physicist Brian Cox has raised the alarm, emphasizing the gravity of the situation. The burning question that haunts us is, are we on the brink of experiencing a supernova explosion so monumental that it will forever alter our view of the night sky? In the infinite expanse of the universe, stars are born, evolve, and eventually meet their demise in spectacular and often bewildering ways. Recently, one particular star has captured the attention and concern of both scientists and the general public alike, Betelgeuse. This extraordinary red supergiant is a prominent feature in the constellation Orion and stands out not just for its brightness, but for the recent phenomena that have sparked increased interest and apprehension. As we delve deeper into the mysteries surrounding Betelgeuse, we may be on the cusp of witnessing a significant chapter in its storied life. But what do these recent changes signify? Are we observing the inception of a cosmic spectacle on an unimaginable scale? Betelgeuse is a colossal stellar giant, approximately 900 times larger than our Sun, a size that challenges the limits of human comprehension. To put this into perspective, if Betelgeuse were to take the place of our Sun, its vast surface would stretch out beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and even Mars itself. This staggering size not only highlights Betelgeuse's physical grandeur but also reveals where it stands in its life cycle. As a red supergiant, Betelgeuse is approaching the twilight of its existence, expanding and cooling after having undergone nuclear fusion processes that convert hydrogen into helium in its core. Estimated to be between 8 and 8.5 million years old, Betelgeuse has undergone dramatic transformations over millions of years to become the remarkable red giant we observe today. It is now entering its final stage as a red supergiant. Stars of Betelgeuse's magnitude experience profound changes throughout their lifetimes due to the relentless interplay of nuclear fusion and gravitational forces. What sets this phase of Betelgeuse apart is its striking reddish hue, a result of its cooler surface temperature compared to other stars, like our Sun. While the Sun's surface temperature hovers around 5,500 Kelvin, Betelgeuse's surface temperature is approximately 3,500 Kelvin. This cooler temperature causes Betelgeuse to emit light at longer wavelengths, giving it that characteristic red appearance. However, this color signifies more than just aesthetic beauty. It provides insights into the physical state of the star and the intricate processes occurring within its massive gaseous envelope. The color of Betelgeuse has evolved throughout history. Records from ancient Rome and China describe Betelgeuse as appearing yellow around 2,000 years ago, while Arab astronomers in the 9th century were the first to note its transition to red. This evolution in color not only reflects Betelgeuse's physical changes but also underscores the star's dynamic life story as observed by humanity over millennia. Additionally, Betelgeuse is classified as a variable star, meaning its brightness fluctuates in a predictable yet complex manner. This variation has intrigued astronomers and casual stargazers for centuries, with Betelgeuse undergoing a brightness cycle approximately every 400 days, complemented by a longer cycle of around 5 years. Notably, Sir John Herschel documented these cycles as early as 1836, with Aboriginal traditions possibly tracing back even further. What adds an air of mystery to Betelgeuse is not just its brightness fluctuations, but also the unpredictable nature of these changes. Unlike many stars that dim and brighten in regular patterns, Betelgeuse sometimes deviates from this expected behavior, hinting at intricate and less understood dynamics within its colossal structure. In late 2019, astronomers and enthusiasts alike were astonished to witness an unexpected and dramatic alteration in Betelgeuse's brightness, a phenomenon that has since been referred to as the Great Dimming. Beginning in late 2019, Betelgeuse, one of the night sky's brightest stars and a defining feature of the constellation Orion, began to dim in an unprecedented manner. The star experienced a fading rate of approximately 0.01 magnitudes per day, and by February 2020, it reached its faintest point. Normally visible even in light-polluted areas, Betelgeuse had become significantly dimmer, and the difference was evident to all who looked up at the night sky. However, observing Betelgeuse presents a unique challenge due to the vast distances involved. The light we see from Betelgeuse has taken nearly 654 years to reach Earth, meaning we are observing the star as it was more than 6 centuries ago. This time lag complicates our ability to monitor and predict rapid changes in its behavior. The dimming event serves as a poignant reminder of the complexities inherent in observing the cosmos in real time and illustrates how much remains unknown about this vast, strange universe we inhabit. As part of a comprehensive 3-year study, Andrea Dupree, deputy director of the Harvard-Smithsonian Center for Astrophysics, and her team closely monitored the dramatic developments surrounding Betelgeuse. Utilizing the Hubble Space Telescope, they tracked changes in the star's outer atmosphere, yielding new insights into the workings of a variable star like Betelgeuse. Their observations revealed that these stars regularly expand and contract, leading to fluctuations in brightness. Hubble's sensitivity to ultraviolet light allowed researchers to observe the star's surface layers, which are heated by swirling convection cells. Through spectra collected at various times during 2019 and 2020, scientists determined that material was moving from Betelgeuse's surface into its atmosphere at an astonishing velocity of about 200,000 miles per hour, eventually creating a dust cloud that diminished the star's brightness for a period of 3 months. Dupree's team noted that an unusually high volume of material, particularly from Betelgeuse's southern hemisphere, had been ejected. This remarkable mass loss occurred at a much faster rate than previously anticipated, prompting astronomers to speculate whether this event might herald an impending supernova explosion, given the substantial mass release and the star's recent faintness. At a distance of 654 light-years from Earth, the enigmatic behavior of Betelgeuse continues to perplex scientists. Should a supernova occur, it would become visible from our planet, providing a rare opportunity for humanity to witness a stellar explosion up close. Yet, the lingering question remains, is this dimming a harbinger of an imminent supernova, or merely a fleeting event in the long, intricate life of Betelgeuse? Numerous theories have been proposed to explain this sudden and dramatic change, but the mystery endures. Share your thoughts in the comments below. If you enjoyed this video, please give it a thumbs up, subscribe, and activate the notification bell to stay updated with more fascinating content. Thank you for watching, and I look forward to seeing you in the next installment.
As the mother of Jesus Christ, the Virgin Mary is seen as a holy figure of the highest order by mainstream Christianity. Islam, likewise, aggrandizes her position as the best woman to have ever walked the earth and regards her as the purest of all. However, interestingly, the final chapter of this holiest of holy figures is a matter of debate and speculation among religious and historical circles. For centuries, scholars and religious believers have been divided over whether Mary, the mother of Jesus, experienced a physical death followed by burial, or if she was taken directly into heaven through a miraculous ascension. Well, we may now finally have an answer, as scientists have finally found the Virgin Mary's tomb, and it revealed something extraordinary. There's a lot to unpack here, so let's get started. Conflicting beliefs about Mary's death. The question of the Virgin Mary's final moments has long been a source of debate within Christianity. According to traditional Christian doctrine, especially within the Catholic Church, Mary is often believed to have experienced a peaceful death. This view holds that she died naturally, after which she was assumed into heaven, a belief formalized in the doctrine of the Assumption. This perspective emphasizes her role as a serene, sanctified figure whose end was marked by divine intervention that preserved her from the corruption of death. In contrast, some Christian sects, particularly within the Eastern Orthodox tradition, have a different account. They hold that Mary did not die but instead experienced a form of martyrdom, which they sometimes refer to as a dormition or falling asleep. According to this view, her transition from earthly life to heavenly glory was not through death but through a divine act that elevated her bodily into heaven, emphasizing her unique role in salvation history. Furthermore, alternative theories and historical accounts suggest various other scenarios about Mary's final days. In some early Christian writings and apocryphal texts, there are hints that Mary might have spent her last days in locations far from Jerusalem, such as Ephesus or other regions where early Christian communities were established. These theories often draw on local traditions and less widely accepted texts that paint a more complex picture of her final moments and resting place. However, now we are closer than ever to finally answering this question. So, what did happen to Mary? And what can her final resting place tell us about her? We'll get to that shortly, but for now, let's get a clearer picture of her life and legacy. The life of Mary, the mother of Jesus Christ. The canonical Gospels and the Acts of the Apostles provide the primary sources of historical information about the Virgin Mary. However, these sources, dating from approximately 66 to 110 AD, focus primarily on the teachings and deeds of Jesus rather than on Mary herself. The Synoptic Gospels, Matthew, Mark, and Luke, were written between 66 and 90 AD, while the Gospel of John, which provides a more developed account, was penned around 90 to 110 AD. Despite their proximity to the events they describe, the Gospels blend historical facts with theological interpretation and legendary elements. For historians, their reliability has been a matter of ongoing debate. In any case, the earliest New Testament reference to Mary appears in the Epistle to the Galatians, authored by Paul before the Gospels were written. Here, Mary is mentioned obliquely when referring to Jesus Christ, who was born of a woman, born under the law. This reference does not name Mary directly but emphasizes her role in the divine plan. In the canonical Gospels, Mary's presence is felt in various ways. The Gospel of Luke provides the most detailed account, mentioning Mary by name 12 times within its infancy narrative. This Gospel highlights her central role in the early life of Jesus, presenting her as a pivotal figure in the narrative of salvation. The Gospel of Matthew also features Mary prominently in the infancy narrative, naming her 5 times and making a single reference outside this context. Mark's Gospel offers a more restrained depiction, mentioning Mary only once by name and referring to her indirectly in the context of Jesus' family. The Gospel of John, known for its theological depth, references Mary twice but does not name her. She appears at the wedding in Cana, where Jesus addresses her as woman, a term that, while seeming impersonal, was culturally neutral and could be used respectfully. The second reference in John describes Mary standing near the cross during the crucifixion. The Acts of the Apostles, written by the same author as the Gospel of Luke, mentions Mary briefly in the context of the early Christian community. She is described as being among the apostles and other followers gathered in the upper room after Jesus' ascension. In the book of Revelation, Mary is symbolically represented as the woman clothed with the sun. Regarding her genealogy, the New Testament offers minimal information. The Gospel of Matthew provides a genealogy of Jesus through Joseph, identifying Mary only as his wife. The Gospel of John mentions Mary's sister but leaves her identity ambiguous. Some early Christian traditions, including those of Jerome and Hegesippus, suggest that Mary's sister may have been Mary of Clopas. However, this is not universally accepted. The Gospel of Luke offers a significant detail by linking Mary to Elizabeth, wife of the priest Zechariah, suggesting a kinship with the priestly line of Aaron. This connection hints at a potential dual lineage, combining both the royal line of David and the priestly line of Aaron. Some believe that Mary's genealogy, reflected in Luke's account, represents a different line from Joseph's, connecting her to the tribe of Judah and Davidic heritage. In any case, Mary's early life is described in the context of her betrothal to Joseph, a common Jewish practice at the time. During this period, she receives the Annunciation from the angel Gabriel, who reveals that she will conceive Jesus through the Holy Spirit. Her acceptance of this divine message and her subsequent visit to Elizabeth are key moments in her story. The Gospel of Luke provides a significant account of Mary's role during the Nativity. According to Luke, the Roman Emperor Augustus issued a decree that required Joseph to return to his ancestral city of Bethlehem for a census. Accompanied by Mary, who was pregnant at the time, Joseph traveled to Bethlehem, where Mary famously gave birth to Jesus in a manger. The exact age of Mary at this time is not specified in the text, but scholars have inferred it from historical and cultural contexts. In that period, Jewish girls typically married shortly after reaching puberty. However, marriages generally occurred later in Palestine and the Western diaspora compared to Babylonia. Estimates for the age of a Jewish bride during this period range from mid to late teens or even early 20s. Following Jesus' birth, Mary adhered to Jewish purification laws, completing her ritual purification after 40 days by presenting offerings at the temple in Jerusalem. This ritual was in accordance required a burnt offering and a sin offering. Additionally, Mary and Joseph presented Jesus at the temple, as the law mandated that every firstborn male be dedicated to the Lord. This moment was further marked by the prophetic declarations of Simeon and Anna, who recognized Jesus as the Messiah. After fulfilling these obligations, the family returned to Nazareth in Galilee. The Gospel of Matthew provides additional details about Mary's life. It describes the visit of the Magi from the east, who came to worship Jesus. Following this event, Joseph was warned in a dream about King Herod's plot to slay the infant Jesus. In response, the family fled to Egypt, remaining there until Herod's death. After returning, they settled in Nazareth rather than Bethlehem due to the rule of Herod's son Archelaus in Judea. Mary is also mentioned in the only recorded event from Jesus' adolescence. When Jesus was 12 years old, he stayed behind in the temple in Jerusalem, conversing with religious teachers while Mary and Joseph returned home. They found him after 3 days, and he expressed his divine mission by stating, "Did you not know that I must be in my Father's house?" During Jesus' public ministry, Mary was present at the wedding at Cana, where she prompted Jesus to perform his first miracle of turning water into wine. Mary also appears in several passages alongside Jesus' brothers and sisters. The Eastern Orthodox tradition holds that these were children of Joseph from a previous marriage, while Roman Catholic tradition considers them to be Jesus' cousins, children of Mary's sister. Protestant views often interpret them as Jesus' full siblings, born to Mary and Joseph after Jesus. Mary's presence during the crucifixion is also noted in the Gospels, where she is depicted standing near the cross with other women, including Mary Magdalene and Mary of Clopas. After the ascension of Jesus, Mary is mentioned as being present in the upper room with the apostles, though her specific role during Pentecost is not explicitly detailed. Pentecost, occurring 50 days after the resurrection of Jesus, marks the descent of the Holy Spirit upon the apostles, empowering them to preach the gospel in different languages and marking the birth of the Christian Church. While the Bible does not describe Mary's actions during this event, her presence alongside the apostles suggests her continued support and participation in the early Christian community. Given her unique role as the mother of Jesus, many traditions consider her a spiritual figure of unity and prayer during this pivotal moment. And that's pretty much all we know about Mary. Interestingly, Mary's later life and death are not recorded in the scriptures. Orthodox and Catholic traditions maintain that she experienced a natural death known as the Dormition. According to Mary's body was then assumed into heaven, an event celebrated as the Assumption of Mary in the Catholic Church and recognized by various Christian denominations. This belief in the Assumption is a significant aspect of Catholic doctrine and is also accepted by the Eastern Orthodox Church and other Christian groups. The Assumption of Mary is a significant doctrine within the Catholic Church, officially defined by Pope Pius XII on November 1, 1950, in his Apostolic Constitution, Munificentissimus Deus. In this declaration, the Pope proclaimed the belief that the Immaculate Mother of God, Mary, was assumed body and soul into heavenly glory upon completing her earthly life. However, This belief leaves open the question of whether Mary experienced bodily death before her Assumption or was taken directly to heaven without dying. The Eastern Orthodox Church holds a similar belief known as the dormition of the Mother of God or the falling asleep of the Mother of God. Pope Pius XII expressed in Munificentissimus Deus his hope that the belief in Mary's bodily Assumption would strengthen the faith of Christians in their own resurrection. It is seen as a unique participation in Christ's resurrection and a foretaste of the resurrection that awaits other Christians. However, the traditions concerning the Assumption of Mary vary. In some local narratives, the event is said to have occurred in Ephesus, specifically in the house of the Virgin Mary. This tradition, however, is a later and more localized development, whereas earlier traditions suggest that Mary's life ended in Jerusalem. By the 7th century, the story evolved to include a detail where an apostle, often Thomas, was initially absent from Mary's death. Upon his arrival, he discovered Mary's tomb empty except for her grave clothes, leading to the belief in her Assumption. This event is sometimes depicted in art as Mary dropping her girdle to Thomas as a sign of her ascent to heaven. The teaching of the Assumption became widespread in the Christian world by the 5th century, with formal recognition in the Eastern Church by Emperor Maurice around 600 AD. Saint Juvenal, Bishop of Jerusalem, reported at the Council of Chalcedon in 451 AD that Mary died in the presence of the apostles, but her tomb was found empty upon its reopening by Saint Thomas, leading the apostles to conclude that she had been taken up to heaven. The traditions surrounding the Assumption of Mary have deep roots in early Christian history, according to various scholars. Researchers have traced these traditions back to apocryphal texts such as the Liber Requiae Mariae or the Book of Mary's Repose, which is believed to date from the 2nd or 3rd century. This narrative, alongside the 6 books Dormition Apocryphon, provides early evidence of Marian traditions, with the latter likely originating in the mid-4th century and reflecting an early veneration of Mary. Additionally, the Greek discourse on the Dormition or the Book of John concerning the falling asleep of Mary, attributed to John the theologian, may precede the Liber Requiae Mariae. This document, dated to the 4th century, further supports the notion of early traditions surrounding Mary's end of life. However, Epiphanius of Salamis, writing in the late 4th century, found no authoritative tradition regarding Mary's end and identified differing beliefs, a normal death, martyrdom, or a non-death scenario. Celebrated on August 15, the Feast of the Dormition was introduced to the West in the early 7th century and evolved into the Feast of the Assumption in the 9th century. Subsequent popes, including Leo IV and Nicholas I, elevated the feast's significance, with Pope Benedict XIV declaring it a necessary belief in 1740. The scriptural basis for the Assumption is debated, with Pope Pius XII referencing passages in Revelation where a woman clothed with the sun is interpreted as symbolizing Mary. This view is supported by various church fathers. Genesis and other texts have also been cited, linking Mary's role to the new Eve and the prophetic type of the Ark of the Covenant. Marian visionaries, including Elizabeth of Skonau and Gilles Bouhours, have also contributed to the understanding and promulgation of the Assumption. The Assumption and Dormition are understood differently in Catholic and Orthodox traditions. Catholics traditionally hold to the belief that Mary was assumed into heaven, with some believing she died first and was resurrected. In contrast, Eastern Orthodox tradition maintains that Mary experienced physical death, followed by a resurrection and assumption into heaven. Among Protestant denominations, some branches maintain traditions like Catholicism. However, the majority of Protestants do not adhere to the doctrine of Mary's bodily assumption into heaven. In Lutheranism, the Feast of the Assumption is observed under different names, such as Mary, Mother of Our Lord, in Evangelical Lutheran worship, and Saint Mary, Mother of Our Lord, in the Lutheran Service Book. Among the Anglicans, the doctrine was largely abandoned after the English Reformation but saw a partial revival in Anglo-Catholic circles during the 20th century. The Church of England celebrates a Marian feast on August 15, which is more generic compared to the Assumption, while other Anglican traditions, like the Scottish Episcopal Church and the USA-based Episcopal Church, have specific designations for the day. The Feast of the Assumption is also observed with public holidays in numerous countries, particularly in those with significant Catholic or Orthodox populations. Interestingly, the day of August 15 was originally associated with Roman imperial holidays and was later adopted by Christianity. In regions such as Andorra, Austria, Belgium, and several others, the day is a public holiday marked by various cultural and religious festivities. In some places, In parts of Germany, Switzerland, local observances reflect the important regional tradition. Although not a state-recognized holiday everywhere, it remains a focal point of devotion and cultural celebration in many communities. The use of the term dormition is found on a sarcophagus located in the crypt of a church in Zaragoza, Spain, dating back to around 330 AD. The concept of the dormition, or the Assumption of Mary, gained prominence in Western Christian art from the 12th century onwards, particularly after the Reformation. During this period, the Assumption was employed as a counter to Protestant criticisms that minimized Mary's role in salvation. In artistic representations, Mary is frequently depicted as being carried to heaven by angels, with Christ awaiting her arrival to crown her, while the apostles gather around her empty tomb, gazing upward in reverence. But what about her final days? Well, there are a bunch of theories about this period of her life as well. One of the prominent stories involves the disciple Thomas, often referred to as Doubting Thomas, for his skepticism about Christ's resurrection. According to this tradition, Thomas was not present at the time of Mary's death. However, when he later arrived, he discovered that Mary's tomb had been opened and was found empty. Some believe that the empty tomb served as a testament to her assumption into heaven. Moreover, Mary's belt, a relic considered sacred, was given to Thomas as a tangible sign of her ascension. This artifact, often depicted in Christian art, is said to have been a physical proof of Mary's assumption into heaven. These stories and their artistic representations contribute to the richness of Christian tradition surrounding the Assumption of Mary, blending historical and theological elements to emphasize her unique role in Christian belief. But what do the experts think about it all? Many scholars argue that the story of Mary's Assumption is largely a product of oral tradition and various sources that evolved. This perspective suggests that the narrative we know today may have diverged significantly from the original events or interpretations. The accounts of Mary's Assumption, like many ancient stories, have transformed through generations of retelling, leading to variations in details. The development of the story is recognized by both religious and scholarly communities, who acknowledge that while the core elements of the Assumption have remained influential, the specifics of the narrative's evolution are less clear. The origins of the story are elusive, with early Christian writings offering varying accounts and interpretations. One significant text in this discourse is the Liber Requiae Mariae, or Book of Mary's Repose, which dates back to the 2nd or 3rd century. This text provides a detailed narrative of Mary's death and subsequent assumption, but it is not widely accepted as a reliable historical source. While it contributes to the broader understanding of early Christian beliefs about Mary, it is seen more as a reflection of developing traditions than a definitive account of historical events.
The universe is an incredibly vast and awe-inspiring expanse, filled with mysteries and wonders beyond human comprehension. While the Earth is a remarkable planet, teeming with life and a unique array of ecosystems, it is but a tiny speck in the grand cosmic scale. The vastness of space stretches beyond our wildest imagination, and our place in it seems minuscule in comparison. Yet, humanity's innate curiosity has always driven us to explore and understand the unknown, to reach out beyond our home planet and discover what lies out there in the cosmos. The advent of advanced technology, especially over the last century, has allowed humans to send spacecraft, rockets, and satellites into space, fueling a never-ending desire to uncover the secrets of the universe. This technological leap has sparked an insatiable curiosity to delve into the unknown, pushing the boundaries of our scientific knowledge. While we have made tremendous progress in understanding the universe's workings, much of what we know is still based on theories, hypotheses, and assumptions. Although scientists have developed reasonable explanations for many cosmic phenomena, much of our knowledge remains incomplete. This is where the Voyager 1 and Voyager 2 space probes come into play. These remarkable spacecraft have been instrumental in expanding our understanding of the universe and its distant reaches. Launched in the late 1970s, these probes have ventured far beyond the familiar realms of our solar system, traveling into the unknown and sending back invaluable real-time data. Their findings have enlightened us about the farthest corners of our solar system and even ventured into the unexplored territories of interstellar space. These are places that humans may not physically visit for generations, if at all, but the Voyagers are our eyes and ears in these distant regions. But as we uncover more about the cosmos, sometimes the data we receive carries unsettling implications. What happens when the information these probes send back contains disturbing warnings or revelations that challenge everything we thought we knew about the universe? What if the very fabric of our understanding is questioned? Join us as we take an in-depth look at the discoveries made by the Voyager missions, particularly Voyager 1, and the alarming messages it has conveyed about the future of space exploration and our place in the universe. For nearly half a century, the Voyager missions have led the charge in space exploration. These twin spacecraft have provided scientists with a treasure trove of data, offering insights into the mysteries of our solar system and the broader universe. The sheer duration of these missions is nothing short of remarkable, considering they were initially designed to last only 5 years. Yet, they continue to operate, far outliving their expected lifespans, and providing an enormous amount of data along the way. The history of the Voyager program is captivating in its own right. It began with the accidental discovery by a young NASA scientist, Michael Minovich, who realized that a spacecraft could use a planet's gravitational pull to slingshot itself further into space. This revolutionary concept allowed the spacecraft to travel much farther than previously thought possible, setting the stage for the launch of the Voyager missions. In 1977, Voyager 1 and Voyager 2 were launched, their primary mission to study the gas giants Jupiter and Saturn. These two planets had long been of great interest to scientists, with their immense size, complex atmospheres, and numerous moons. What the Voyagers accomplished, however, exceeded all expectations. Both spacecraft are equipped with 3.5-meter parabolic antennas that communicate with Earth, along with 16 thrusters to adjust their orientation and ensure their antennas remain pointed toward our planet. Their engines run on hydrazine fuel, and their onboard electronics are powered by thermoelectric generators, fueled by plutonium. In addition to these remarkable features, each probe carried 11 scientific instruments. These tools were designed to study the planets they encountered, from analyzing atmospheric conditions to examining magnetic fields. Over time, as the probes moved further from their original targets, some of these instruments were shut down, but many continue to function, sending back valuable data. One of the most ambitious parts of the Voyager missions was the so-called Grand Tour of the Outer Planets. This tour became one of the greatest achievements in the history of space exploration. Voyager 2, in particular, achieved the distinction of being the first spacecraft to closely observe Uranus in 1986 and Neptune in 1989. These encounters provided scientists with unprecedented views of these distant planets and their moons. Voyager 1, which had overtaken Voyager 2 just a few months after its launch, conducted flybys of Jupiter in 1979 and Saturn in 1980. These encounters made Voyager 1 the most distant man-made object from Earth, a title it still holds to this day. Despite the immense distances both probes have traveled, they continue to operate, with Voyager 2 currently functioning with 5 active instruments, while Voyager 1 has 4. Together, these probes are still gathering valuable information about the outermost regions of the solar system and the vastness of interstellar space beyond. As both spacecraft venture farther from the Sun's influence and into interstellar space, they continue to send back crucial data about the cosmic environment they encounter. This data is helping scientists piece together a better understanding of the space between stars, a region that had remained largely unexplored until now. But before we dive into the mysterious messages Voyager 1 has sent back, let's take a moment to appreciate the profound discoveries these two missions have made along the way. Imagine embarking on an epic voyage to explore the unknown regions of our solar system, with Voyager 1 and Voyager 2 as your companions. Their first mission was to take a detailed look at the majestic Jupiter and Saturn systems, and they succeeded beyond anyone's expectations. The images and data sent back by the Voyagers transformed our understanding of these gas giants. They revealed the intricate cloud patterns and turbulent weather systems of Jupiter, including its iconic Great Red Spot, a massive storm that has raged for centuries. The probes also provided new insights into Saturn's complex ring system, capturing stunningly detailed images that allowed scientists to study its composition and structure like never before. As Voyager 1 moved beyond Saturn and out of the solar system, Voyager 2 still had exciting targets ahead. In 1981, a carefully planned maneuver adjusted its course, setting it on a path toward Uranus. By 1986, long past its expected lifetime, Voyager 2 arrived at Uranus, where it made one of its most significant discoveries. The probe identified 10 previously unknown moons, expanding our knowledge of Uranus's satellite system. These moons had gone undetected by earlier telescopes, but Voyager 2's instruments captured their presence, adding them to the growing list of Uranus's known companions. Yet, the journey didn't end at Uranus. Voyager 2 pressed onward toward Neptune, its final planetary destination. In 1989, it sent back more than 9,000 images of Neptune and its moons, leading to the astonishing discovery of 9 new moons. Among these, Triton, Neptune's largest moon, revealed secrets that astounded scientists. Its diameter turned